Thank you. I hope I am audible. Yes, am I audible?
Yes, sir, you are audible. We can hear you and we can see your screen also.
Thank you, Naseem sir. Thank you. So, a very good morning, one and all present here in this beautiful FDP on cyber security in era of AI. So, thank you for the nice introduction. I would like to extend my sincere thanks to the esteemed organizer of this FDP, also all the enlightened participants of this workshop who had given me the opportunity to deliver this talk over the multimedia security perspective in IoT. So let's begin the discussion. Now, a small acknowledgement, because to prepare this slides, I took some content over the internet and some from some resources. So let me acknowledge those things first. Now let us start the discussion. See, in this entire discussion, actually, I have divided my talk on 4 or 5 important aspects. Firstly, we will begin the discussion from the importance of machine learning, AI, and then some suitable programming language to implement those ideas, those techniques. Later to that, we will discuss about the IoT, Internet of Things. Gradually, after that, we will discuss about the concept of cryptography. Because in IoT, we are already having a number of techniques which are suitable for doing encryption for server, for the computer, mobile phones, etc. But if you think about the RFID tags, sensors, then those traditional conventional scheme is not that much suitable. So we have to think about some lightweight encryption techniques. So that we will discuss later next to that. Subsequently, we will discuss the another aspect, because if you think about this communication, entire communication, then at a sender side, first important part is how to handle the data, and how to get the insights from the data. So that we does in data analysis and data science. After that, the another concern at a sender side is if we are having a big data, then how to handle it efficiently. And for that regard, we have to find out some suitable technique, because if large amount of data we are sending over the public channel, then definitely the communication cost is going to be high, right? So to reduce the communication cost, to reduce the bandwidth requirement, definitely some compression technique is very essential. So that is another aspect which we have to be focused on, how to compress the data, because large amount of data we are supposed to send over the public channel. The another concern which come at the sender side is the data which we are having. Let's say it is a compressed data. How to send this data to the intended user? I mean, over the public channel, who is not intended, he or she cannot read it. So for that regard, definitely we should use some sort of encryption technique at a sender side. And by that way, we can encrypt the data. Not only encrypt, we can also provide the integrity, authentications. So all this confidentiality by doing encryption. So all these essential services we can provide to the data. Now let's assume, I mean, this is the one aspect at a sender side. The another thing which comes after that at a receiver end. Now the data which receiver is receiving, how he can understand that who has sent this data. So that we have to understand. That is one aspect. Second important aspect is the data which we are receiving at a receiver end. That data is erroneous or error-free. It may be possible that during the communication over the public channel, some data bits will change. because we all are knowing that data used to go in a form of bit stream over the public channel. So if any bit, let's say MSB bit or LSB bit will change, then entire meaning of data is going to be changed. But how the receiver will understand that during the communication, this byte sequence has been changed? How he can understand, he or she can understand. And for that regard, we are having a number of techniques of error detections. Let's say by applying a suitable error detection technique, we understood that some single bit error or multiple bit error or burst error has occurred. Fine. So that is not only the concern that we have recognized that data has been changed. If it is like that, so we can decline the packet and again we can ask for the sender to resend the data. That is the one aspect. Another aspect is receiver herself can detect it and also correct it. So error detection and correction technique is another aspect which I will try to brief on in my fourth section of this presentation. Next to that, I will discuss about this image and video data, because image is having redundancy, video is also having a temporal and spatial redundancy, how to remove it. And not only this compression part, we should also understand how to encrypt this image and video data for the secure communication over the public channel. Now again, in image and particularly video, if I will talk about, so two things can be done. We can firstly encrypt the video stream first, followed by compression, because we have to compress the data so that the communication cost will be the lower, the otherwise bandwidth requirement will be more. Or reverse also we can do. Firstly, we can compress followed by encryption. Third approach is simultaneously we can encrypt and compress the data, right? So that is the three aspect we will discuss at the last topic of this discussion. So let us begin the approach first. So what we does, to implement some idea, because see, as a computer science people, our what we does, we used to get the requirement from the user end, right? And once we understand that problem, so we have to find out the suitable technique through which we can solve that problem. We have to understand that the feasibility study first, either the problem which is given to you, that is feasible or not, right? And once that problem is feasible, the another concern is how to solve it, right? For solving regard, again, because if you because we have learned about the algorithm, so we know the number of approaches we are having through which we can solve the problem, right? So after getting the user requirement, it is we who have to decide the appropriate policy through which we can solve the problem. And then for that regard, we are supposed to write the appropriate algorithm, right? So that is the initial task which we does. And once we finalize the algorithm, once we finalize that this given problem, either we should apply divide and conquer approach, or we should apply the green technique, or we should apply the backtracking. Number of approaches we are having through which we can solve the problem. It is depend on the user requirement, it is depend on the problem definition. Accordingly, we have to select the proper approach. Once we finalize the approach, we have to figure out the suitable algorithm for that regard. And once we write it down, the next thing which comes into the picture is the implementation of that algorithm, right? So we have to find out the suitable programming language through which we can solve that that algorithm which we have planned for. So again, for that regard, the platform is required. Either you want to implement it in C, C++, Python, or other suitable programming language which is suited for that regard. So that we have to select. The another thing after that comes the editors, right? We have to find out the suitable editors through which we can implement that algorithm, right? So our basic task, which from where we begin, is the user requirement, and then we have to start the implementation of that thing. Now, this is something which we does, all the computer science people do from these slides. What we does, we used to write the program over the editors, and based on the user input, we use to run that program. And if that program is working well, that is well and good. We will try to supply more and more input. And if it is working well, it means yes, we have done it. We can implement the idea which user has given to us, for which we are, for the regard we are writing this program. So we have done that. But if unfortunately, if your program is not working for the given input or for the some more input, then again we have to rewrite, we have to modify the program, and we have to customize it accordingly, right? So this is something which is our day-to-day life, right? We used to encounter with this, and from where our journey will begin, right? Now, the next thing is this, because this is it is story of all of us, right? Because well, either we are guiding a PhD students, or maybe as a computer science people also. This happened with all of us. Once we get the idea, we easily find out the outline of that, and we become happy that yeah, it is very easy, we can implement it. But the coding part is very essential. Once we try to transform the idea into the coding aspect, then the life will become a hell, right? Because sometimes it's not that much easy to implement the entire thing as it is. So this is something where we every day used to encounter this problem, right? So what to do and how to efficiently solve the problem, that is that make us better from the others, right? The next thing where we become happy is this, right? So once we debug the program, if the one error is gone, then if another error we are getting, then we become happy. That is the life of programmer, right? So that is how we day to day we are living our life. Okay. Now as I told you, the important aspect of this implementation is to find out the suitable programming language. When we talk about this machine learning, deep learning, AI, then by default Python come into the picture, right? Now the question is, why machine learning and AI we all are talking about? Because nowadays these all are the buzzword. Lots of discussion, lots of research are going on in this area. So the question comes suddenly, why only this machine learning or AI is that much important? Let me create a background to understand about this problem. Now, we human beings every day are creating an enormous amount of data. If you think about our, the beginning of the day to the end of the day, we used to create lots of data in terms of, if you think about the, your hospital bill, maybe your Facebook, Twitter, telephone bill, maybe the newspaper, news articles, mail, spam, images, videos, SMS, right? Lots of things, I mean, we all are doing every day. So just think about the human population which we are having across the globe, and everybody is encountering this thing every day. Every day they are creating the huge amount of data. Now the concern is how to handle this data efficiently. Now the question comes, why we are discussing about the handling of this data. Why we want to read this data? Because the data which we have created in our past, why those data are important? So if you see the recent studies, so it has been proved that if you analyze the previous data, the data which we have created related with any organizations, if you read those data efficiently, I mean, if you try to find out the insights of those data, then you can make a more business. So it has been found that the organization which is studying their previous data, they can make more 20% more business than the others who are not reading those data. So if you take some, very generalized example, I mean, let us think about some ice cream manufacturing company. So it is but obvious that during the winter, their sales will go down rather than the summers. So it is not very good idea that during winter also the production will produce that much amount of ice cream which they are producing during the summer, right? If they will do so, then definitely they will get a huge loss. So if they will see the previous year record of data, how much they have produced, where the cells go down. Accordingly, they can plan their next year project. They can plan their next year project and they can make a more business. So this previous year reading, this data analysis which they have accumulated during their past, that analysis of data is very much essential to get the benefit in the organization. And this is where our machine learning come into the picture, because by using a machine learning we can perform the predictions, right? So we can predict about number of application machine learning is having. So generally where we use this machine learning is to perform the prediction task. For example, either this India is going to be win match today or not, either we are going to be rain today in this region or not today. This forecasting analysis. We can also predict about the house rent, house price in NCR region, maybe any reason. If we are having a previous data of the municipal corporation, we can take this data, we can perform, we can make a model, and accordingly we can perform the study and we can predict about the current rate of that locality. So by using this machine learning, basically we can perform the prediction, and that prediction will help us. Maybe if think in this way, the data which we are receiving, that is the mail or spam, right? The classification issues. So the data which we are receiving, we are predicting it, either it is a spam or mail, right? So all this study we can do by using this machine learning concept. So the concern which we were discussing is why Python is essential, because it is having some beautiful attribute. If you see this, I mean, it is having a nature of it is having attribute of POP and OOPS property. POP is what? Procedure programming language, right? So I mean, if you think about C programming, where we used to write the program with the use of functions, right? So that is a POP. What is the OOPS? We define the class and object, right? The C++ Java is the example of that OOPS property which is having. Now this Python is having both the quality. I mean, this having a quality of C as well as having a quality of OOPS, C++. So as well as we can derive the useful conclusion from the vast data, which is very tedious job for the other programming language. That's why this Python is very suitable platform through which we can perform this machine learning and deep learning data science work altogether. Now, let us build the concept of machine learning. Why machine learning is essential. So for that regard, let us move on the discussion. Let us see this. Okay, this history of Python, I mean, who has invented it? The guy's name was Guido van Rossum, and he's having a show. His name was the Python Flying Circus. From here, he took the name of Python and he has proposed the name. Now let's see this image. It is having a two object, cat and dog, right? Now, if I will ask you to write a program which detect the image of object, right? So if you choose any traditional programming language like a C, C++ to recognize it, it is going to be very, very tough, because for each edges, curve, textures, you are supposed to write a different functions for that regard to recognize each and every attribute of that. So it is not going to be that much easy program at all. Let's say I believe that you have written the program to identify this cat and dog of this image. What if, as I told you, it is very tedious programming, which if you write it for the cat and dog, what if I will change, if I will give some other image to you, and that image belongs to cat only, right? Now, the program which you have developed earlier to recognize cat and dog, that program may or may not, I think it is not going to be work, because here it is having different textures, different edges. Again, you are supposed to rewrite the entire program, even though it is an image of cat. So I mean to say, it is very tedious. I mean, I cannot I cannot utilize the program which I have developed earlier as it is for this one, because to recognize the image of cat, already we have developed some program. that we cannot use as it is, may or may not, maybe sometime. Now, let's say I believe that you have again written a program to identify this image of cat. Let us believe that by using a traditional programming language. What if I will change this image? Now, over the different angle, I took the picture of cat. Now, the program which you have developed for the second image is again not going to be work as it is for this image. I hope you're getting my point. Because again, here the angle is different. Again, the textures, edges, again, we are supposed to, maybe some modules we may use, but again, may not entirely program you are supposed to rewrite, right? Now, let's say again, I'm believing that you have written the program for this one. What if I will give you the image of this one? Now, this image is having a 3 object, you may say this cat, dog, and horse. Again, the program which you have written earlier to recognize cat, dog, again, it's not going to be work as it is for this image. Again, you are supposed to come up with another piece of code to, again, you are supposed to rewrite the entire program for this particular given image. What I want to create a background to understand why this machine learning is going to be help us. Because see, if you see all these images, for each images, we are supposed to rewrite the entire program again and again, and again. That is not a good idea at all, right? Then what is the remedial choice? Because for the same image, for the same object, let's say object of cat, again, we are rewriting the entire program. If we are using some traditional, approach we are using by C++, we are writing the entire thing again and again. Then how to solve this problem? Because for each small changes, rewrite the entire program. Small changes, rewrite the entire program to recognize that is the image of cat or dog, right? Again, the entire thing is not good. This entire approach is not good as it is. So we have to come up with some sort of solution through which we can solve this sort of problem. And the remedial choice is the machine learning. What we do in machine learning, we create a model, right? We create a model. So for that regard, the idea is we have to train the model by giving lots of image of cat and dog. Once this model is ready, now that model is going to be help us to recognize any unseen input, right? So my model is ready. See, I have trained my model by using this cat and dog, lots of image of cat and dog with a different angle, different dimension, different attributes, different edges, right? Once my model is ready, what this model does, if unseen image of any object I will get, my model will check it out and it will predict that it is the image of cat or it is the image of dog based on the training which we have had. Now, it is something analogous to our human brain. See what happened. If you think about our human perception, we see some object. So how the image of that object we understand that it is the image of a chair or bench. Actually, what happened? The light used to come from that object to the certain portion of eyes, and then with the use of neural network, that image, that light went to the certain portion of brain, and there already some understanding about the shape, color, size, object already we are having pre-stored in somewhere, right? So the input which we are getting and the the predefined the images, shapes, color which we are having, both our mind used to compare, and based on that learning which we are having and the input which has come into our brain, both things will compare, and then we used to understand that it is the image of cat, table, chair, copy, pen, pencil, or whatever it may be, right? So we are having some predefined understanding. By using that understanding, we used to understand the new image. Just like if you think about a baby boy, the new baby boy, how they start learning the things. We used to tell them this is a mouse, this is a this is apple, this is a banana. Accordingly, they see the color, shape, size, and they used to start the perception that it is a cat. They never ask you that it is a apple or mango, whatever you teach them, they take it as it is for their understanding. And whenever some new object, new fruit has been given to them, they used to tell by their understanding that it is a image, it is a apple, a banana, a mango, whatever. The same thing is happening. Same thing we are trying to put by using this machine learning concept. Firstly, we train the model by giving lots of data. Once my model is ready, so we are having some approach through which we can make the model. We check the accuracy of the model. Once my model is acceptable, then the model we will deploy for the for the market purpose, for the deployment we used to go. Once the accuracy of the model is correct, what that model does, it performs the predictions. It's seeing some unseen data. Once you've given this unseen data to the model used to predict that it is a cat or dog or whatever it may be. This concept will solve the problem which we have discussed earlier by the image of cat and dog. No need to be write the entire program again and again. We can predict the given image is having a cat, or it is an image of dog, or it is an image of horse, right? So this is somewhere this machine learning will help us to solve this complex problem which we have discussed earlier. Now, in this machine learning, basically, we are having some steps which we have to follow to make the model. First thing is data. We have to perform the exploratory analysis. That is a pre-processing sort of things. And then we used to split the data into training testing. We create the model. Then we used to train the model. We perform the prediction and so on. Now, as I told you, for this machine learning, we used to use this Python programming language. The reason being is this: if you see this program, if I will ask you to write the program for to 100 times your name, then if you're applying this C programming, then you understand that it is number of line of code you are supposed to write. The same thing we can do by using a Python programming within a single piece of code. So it means that there is we can make the things easier, better for the user, right? And it is also readable. Anybody can understand it by reading it is not very complex. It is not very tedious to understand it, right? So this Python make the life very easy. That's why this Python is very well acceptable across the globe for implementing this idea of AI particularly. Again, the next popularity, why Python is getting the popularity is this one. I mean, here we are having a number of community through which we can post our query, and a number of people will come ahead to solve your problem. So that is something very beautiful about the Python. See, I've come up to 5 minutes. आप बंद कर दें, 5 मिनट बाद आए, आधे घंटे बाद आए. Close it. Sorry for the interruption. So here, as I told you, number of communities we are having which will come ahead to solve the problem. So here you can easily find the code partner. If you're getting some trouble, just post your query, or the number of platforms we are having on which we can perform the query. So many people will come ahead, they will suggest so many things. No need to be asked your lab mate or your supervisor for that regard. Just post the query, somebody will come ahead and they will tell you something, and by which you can get the idea, or somebody will even solve the problem. So many rich community it is having. That's why Python is getting popularity. And number of channels are there through which you can learn this Python programming. So you may see here, for doing this data science or AI particularly, or machine learning particularly, this Python is having very crucial role to solve it, right? Now, these are the detailed thing of Python programming, because number of libraries are there through which we use, we can implement this machine learning concept. So these are the basic things which are important to perform the machine learning task. This is the core syllabus. Let us keep this. This is a basic intermediate. I mean, again, I'm speaking, it is a part of Python programming. So let us don't discuss this part again. These are the famous editor through which we can perform the this implementation part. I generally prefer this Jupyter notebook. It is up to you which one you want to use for doing the implementation of this machine learning work or AI work. These are the container sequences. Let us keep this part. Now, this is important. there are number of libraries in Python. More than 350 libraries are already existing in Python, which are dedicatedly developed for doing a dedicated task. So if you see that this NumPy is basically we use for numerical computing. We are having a matplotlib for visualization of the data set. We are having a Seaborn also. Here we are having some customized, customization we can do by using the Seaborn library. Again, it is for the visualization only. We are having a pandas, just like a DVMS. We are having SQL table type of things. Here we can import the data in form of table. So that Panda will facilitate us. Scikit-learn we are having for the machine learning work. So the important why I'm discussing about this Python is because we have to do the implementation of cryptography, right? For doing a cryptographic work also, we are having a dedicated library for that. So if you want to perform any traditional encryption technique like AES, DES, RC4, or maybe some hashing you want to perform, you want to crack the hashing, all these things are already existing algorithms we are having. Only we have to recognize the class of that particular thing. And we have to call that class, we have to make an object of that if it is required, or we have to call that class all the facility, all the associated function we can use for doing an encryption decryption work. So the famous library, which I personally a number of times I have used that is a cryptography. So I will show you one demo how this cryptography. Let me show you that first. So in Python, hopefully everyone is knowing. So is it visible? My screen is visible. My screen is visible.
Yes,
My
it's
screen is
visible.
No, sir, only slides are visible.
only slides are visible. Okay. No, actually, I want to show you this one. One participant can share. I don't know how to change this part. One participant. Just a moment, please. This one. Now check, please. Now I hope you are getting this Jupyter.
Yes, yes, sir.
Yeah. Now see, I have created one IPYNB file to implement this encryption decryption. Is it visible now? Jupyter
Yes, sir,
encryption decryption.
it is visible, sir.
Visible, right? So you may see here we are importing this cryptography library. Now here we are having this fernet. We have to call the appropriate class for doing the implementation of encryption decryption. So here actually we are performing the encryption and decryption part. For that regard, I have firstly you have to include this library into an environment. So we are having some command for that regard, pip install cryptography. So by that way, this cryptography will come. See, all this machine learning related work, already all the associated libraries are already pre-installed in this Jupyter environment. But if you want to perform this cryptography work, you have to include this cryptographic library. For that regard, we are having command pip install cryptography. Now see, now I want to perform the encryption decryption, right? So I'm calling this fernet class, which is available in this cryptography library. So once I have done it, now I have to generate the key. So if you are having I hope you are having understanding about the cryptography. So at the sender side, we are having a data. If it is symmetric encryption, there is a requirement of key. So by using this key, we used to perform the encryption of this data, and the cipher we used to send over the public channel. The same thing used to happen in the reverse way at the receiver end. He is having a key, he is getting the cipher, he will apply the reverse operation of the encryption algorithm, and he will get back the plain text. The same thing we have done over here. We have generated the key, and we have to call this fernet class, and we are generating the key. We are keeping the key over the key variable. Now I'm putting this. I'm creating a file. In this file, I'm putting all these keys all together, and then that I have written. Now by this way, we are creating the keys. once you have created the key, you will get it. I mean, this secret key is come over here in the environment which you are working with, right? Secret key is here. So once we have done it, now the another part is we have to perform the encryption, because now key we have created. The another thing is by using the key, by using the data, perform the encryption. The same thing we are doing in this function. Function definition is encrypt message. It will take message, it will take the key which you have created, it perform the encryption, encoding we have to do. And after that, we have to perform the encryption. Once encryption we have done, the message, encrypted message we will get. Right? So now by using, I'm calling this function which I have created to perform the encryption, and I'm encrypting this message. Hey, I'm Manoj. So once you have done it, now see, this is the encrypted message which we are supposed to send over the public channel, right? So once this message will go through the public channel, the receiver will receive it, and he will apply the reverse of the encryption. That is the decryption process we have to do. The same thing which you have to do, because see, for the symmetric encryption, the same key should be there with the receiver end. So same key he will load, and then he will perform the decryption. And via decryption, he will get back the data which you have sent. I mean, he will. I mean, the cipher and the key, both the decryption will happen. Again, it will. You will get back the message which you have sent. Right. So this is the overall idea. I mean, gradually you will take it in more detailed way. But this Python platform will help you to do this task in very efficient, very very easy way. Right. Only the thing is you must understand the classes, because number of classes for doing a particular algorithm, we are having a different class. So we have to understand which class is regarding for what. Once we are having this idea, we can directly call that, and we can perform this encryption, decryption, number of pre-existing algorithms we can implement very easy, right? By using this Python programming. Now again, come back on our discussion. My slide is visible, I guess. My slide is visible. Slides are visible, please. Any one of you? Can you confirm this? Am I audible?
Yes, yes.
Yeah, thank you, sir. Thank you. Now, these are the some predefined library. As I told you, 350 libraries we are having. So these are the predefined. But for doing cryptographic work, as I told you, number of existing library we are having, which is defined for cryptographic work, so that you can check. Now the machine learning, in a very brief way, again, I am representing it. So this is a one aspect of how human learns. Same thing, we are analogous to that. We want that machine will learn by seeing the events as human brain used to trained. Same thing, we want that machine will also perform the same thing. By seeing the data, the machine will train, and once the machine will train, it will perform the same as it is as the human brain used to do. So as I discuss this part, right, how this machine learning will work, and these are the steps how this machine learning work will carry on. Now, basically, if you see this machine learning broadly, we can categorize into three parts: supervised learning, unsupervised learning, and reinforcement learning. Now, in supervised learning, again, it is based on the data. Based on the data, we have to select which approach we have to use. If your data is having a label and corresponding output, कुछ देर बाद आए आप बंद करें, कुछ देर बाद आइए. Sorry. So based on the input data, we have to understand that in the given data is having a label and corresponding output. If it is yes, then we have to apply the supervised learning on that. But if your data is not having a label and attribute, the corresponding output, means we have to apply the unsupervised learning on that given data. So it is we who have to select. By seeing the data, we have to select either which technique we have to use for doing the machine learning work. Now in supervised learning, basically two things we use to perform, that is a regression or classification. So if your data is, if we have to see the target variable, the outcome, if outcome is having a numerical values, then we used to apply the regression analysis on that for doing the prediction work. If your target variable is categorical, it is having a limited outcome, yes or no, or maybe some, some 3-4 type of things, categorical outcome if you are having, then we have to apply the classification. Similarly, for the unsupervised clustering associated dimensional reduction means PCA, hopefully many of you are knowing principal component analysis that we used to apply in unsupervised learning. Clustering to check the, the similarity among the data set, we used to apply the clustering on that. Now, the next thing is supervised learning. As I told you, the supervised learning we can further categorize into 2 parts, regression and classification. So again, based on the target variable, it is we who are supposed to select the suitable technique, right? What we want to do. So regression we particularly apply when the target variable is having a numerical outcome, right? Then again, here we have to select the appropriate one. Either we should apply the linear regression, or bridge regression, or multiple linear regression, or polynomial linear regression, or lasso regression, right? Or elastic net regression. Which regression we have to apply, that we have to understand. We have to decide by getting the user requirement. So generally, we used to apply this linear regression once we are having, in linear we are having a multiple linear regression also. So if in your data set, if number of attributes you are having, then we used to apply the linear regression, provided it satisfies the characteristic of regression, right? Because some characteristic it must satisfy, then only we can apply the linear regression. They must have some dependency. Each attribute and the corresponding target value, they should be linearly dependent. If one is increasing, second one should a target value should also be impacted by that. The second attribute should also depending or influence the target variable. Third attribute should also influence the target variable. So there are some predetermined, some basic characteristic of regression that must satisfy by your data. Then only we can choose the regression analysis. Otherwise, we cannot use that. So now the important thing, the problem which comes in this regression analysis is overfitting, underfitting issue. Sometimes what happens, it may possible that the model which you have created, it works well for the training data set. Because see, you are having a data, you have divided this entire data into 80-20 split or 70-30 split. The 80% of data you took for training the model. Remaining 20% data we will take for for doing the testing purpose. So it may possible that your model is working very well for the for the training data set, but it not perform well over the testing data set. So it means what? Your data it is having a low bias and high variance. Your model is overfitted, right? So this overfitting, underfitting comes into the picture, right? So if it is like that way, then accuracy of the model is going to be hampered. It is not well accepted, right? So what to do? How to reduce this problem of overfitting, underfitting? For that regard, we are having a number of ways we are having through which we can do it. The important one is, if you are getting this problem, the best way is abort the model, come up with another algorithm, use some another algorithm, and again make the model. That is the first approach, very obvious approach. Or we can use k-fold cross validation we can apply to reduce the problem of overfitting and underfitting. Or the third approach we generally choose, that is a regularization. We use to find out the lambda, and that is the somewhere ridge regression, lasso regression, and elastic net regression come into the picture. Basically, we use two separate model for training and testing. We use a two separate model for that regard, that we used to do in ridge regression. We use this lasso and elastic net for finding out the influencing factor. See, it may possible that all the features which you are having, they are not equally important to predict the outcome. Sometimes few factors are very influential to predict the outcome instead of others. So we should not collect all this data because see, for the training purpose also, it consumes the time, lots of data it will take. So unnecessarily we are doing this exercise. We have to find out only those attributes which are impacting on the final your target value. Or we should only find out the most influential features which are impacting on the target variable. And by using that only, we should perform the predictions. For example, see, if you talk about this lasso regression or elastic net regression, then if you see any property price, right? So if the property belongs in Jammu particularly, so in peak area of Srinagar, then definitely you will not see the other factor, because if it is in Srinagar and it is having a good locality, you will not bother who are the resident near to me, or you may be not bothered that how much away the market is, or you may not be bothered about the other connecting feature. The prime feature is it is in main Srinagar, right? So sometimes only one feature itself is sufficient to predict the price of that. For example, if you see the price of Bangalore property, so Bangalore means obviously the property rate is very high. If you see the other factor also, sometimes we have to ignore. We have to see either it is in Koramangala or not. See, Koramangala, it's not equally same. It is some interior, some exterior, but Koramangala is Koramangala. So number of features are there which influence the final price of the property, but sometimes we are only seeing the most influential feature. And that actually we used to identify using a lasso regression and that elastic net. Okay, let's move on because so many things are there. So classification is another thing. So as I told you, if your target value is having categorical outcome, we have to apply this classification. Number of algorithms are there through which we can do this classification. For example, the receiving mail is spam or ham. So how can you check it out? The data which you are getting, how can you check that it is a spam or it is a proper mail? Right? So that is a classification. What is the outcome to? Either it will be mail or it will be spam. Correct? So that classification we can do by using the suitable technique. I mean, logistic regression, naive-Bayes, KNN, SVM, these are the example of performing the classification. Now, this is a data science, AI and ML, because it is sometimes AI is a bigger umbrella, everything comes under that, right? So ML is a subset of AI. This data science, under this data science, everything will come into the picture, right? So either you are doing a deep learning, or you're doing an ANN, or you are doing a machine learning, they all comes under the same umbrella, right? Now, this is something which is happened because right now the good opportunity of job comes in the area of data scientists. So basically our understanding is if you know the machine learning, then your task is done. You become a data scientist. Or you know the deep learning, you become a data scientist. So you must see the distribution. 80% people think that machine learning is sufficient for doing a data science work, or 20% is a contribution of deep learning, but that is not the reality. Reality is the next image. First and foremost important, because see, for writing any program, the first thing to understand that program, understand that problem particularly. So this understanding of problem is the more crucial task. If you understand that, if you define the problem in a well way, then everything, rest of the things will become a very easy, or very cascade manner you can do that. But if first step is wrong, then entire exercise is going to be ruined out. So this is the actual distribution of the task. So supervised learning I have discussed. So let us see this very important line for our day-to-day life. If life gets a scattered plot, then be a regression line, be a connecting aspect. If somebody is going apart from you, just become a regression line, put them together. That is that is the meaning of this beautiful line. So sometimes this concept also teaches so many things to make our life better. Okay. This is unsupervised learning. So I'm not wasting more time on this. Let's move on. So it is unsupervised, as I told you, if there is no labels, there's no target value defined, then in that case, we have applied this unsupervised learning, and clustering, dimension regression, associated analysis we used to perform over here. Let's move on. So this is actually steps of machine learning, how this machine learning perform. So if you're interested, so this is actually a step which we have to do to make a model, right? This is a regression line, how regression work, what is the good and what is the bad in regression. So that part I'm not discussing right now. Let's move on. Now, So let us discuss this, the concept of this IoT. So basically, actually, this is the second part of my presentation, the second section of my presentation, because we have completed the Python and machine learning part. Now, next is IoT. So basically, IoT enables many low resource and constraint device to communicate, compute, you may say that make decision in the communication network. So the first, if I'm not wrong, then this IoT basically comes in the year of around 8082. So that was the first Coke vending machine. Now from the duration of this 1980 to 2023, as per the Gartner, around 9 billion plus enterprise and automotive IoT endpoints will be in use. And that is evident. This 9+ figure is evident that IoT is growing in multifold and will continue to grow in in the upcoming couple of years. So basically, with this understanding, you may understand that this will provide unprecedented opportunity for the users, the manufacturers, service provider in a wide variety of sector, right? So 9+ billion, that much big figure you are having, right? नहीं, आपको मना कर रहे हैं आने के लिए ना, गार्ड नहीं, बाहर जाइए, बाद में साइन करेंगे, निकलिए यहाँ से, बंद करिए, कह दीजिए 1 घंटे बाद आइए. Sorry. So if you see the dimension of this IoT, then almost all the sectors like health, fitness, healthcare, home monitoring, automation, energy saving, smart grid, farming, almost all the sectors are right now using the concept of this IoT, right? So if you see the application domain around if you see the manufacturing industrial business, 40% work is going on through IoT. Healthcare is using 30%, security is using 7.7%, retail is having 8.3%. So you may understand the importance why we are discussing this IoT at all, because all the sectors are right now using this IoT concept. Now the characteristic of IoT. So it is a massively scalable, efficient, IP-based addressing will no longer be suitable in upcoming future, because it is all the devices which is having over this channel, everyone is not having an IP, right? So the device that is connected to another device right now may not be connected in another instance of time, right? Intermittent connectivity, the IoT devices are not always connected. In order to save the bandwidth and battery consumption, device will be powered off periodically when it is not in use, right? So many beautiful characteristics of IoT devices are having. Now the advantage of this, the IoE. So, you have heard about the number of sensors actually, which we use, like we are having a temperature sensors, image sensor, gyro sensors, obstacle sensors, RF, this LDR, ultrasonic distance sensor, number of sensors actually we use for gathering the data, and then we use to pre-process and we used to send to the cloud, and all the pre-processing used to be happen over there. And accordingly, command used to go through the actuators, right? This is something through which the entire operations are performed. So basically, we use IoT to cost saving, improve the decision making. All these are the advantage why we are using this IoT concepts. Now, working with this IoT. So for this purpose, what actually we does, the sensors are widely used. They are used to as per the requirement in different applications area. That sensors used to collect the data and transmit the data, right? The second thing is actuate device based on the trigger produced by sensor or processing device. So if certain conditions are satisfied are according to the user requirement, if certain triggers are activated, then which conditions to be performed? That is through the actuator we used to perform that. Then we are having this receive information from the network device. User or device can take a certain information also for their analysis and pre-processing we used to perform there, right? Then communication assistance, number of this actually communication, different communication protocols we use like a Zigbee, FDP, HTTP, right? All those communication protocol we use for doing a communications. Now with the advantage, definitely with the advantage, the another thing is a disadvantage also come into the picture, right? With the advantage, disadvantage also come into the picture. I mean the complexity and increase the maintenance requirement, right? If number of IoT devices, numbers based on that and different location deployment is having, so maintenance requirement is having. Initially, the investment cost is going to be very high. It is having a limited, the battery life, right? And the bigger issue of this IoT, which impacting on the human life, is the job displacement due to the automation. That is the biggest disadvantage of this. I mean, definitely with the advantage, disadvantages are also associated. So with all these applications and with all this detail, one thing is very much evident that IoT era begins. So what basically this IoT era does? So I mean, this with the IoT means anytime, any place, anything in connectivity. That is the meaning of IoT, correct? So basically what this IoT does, this IoT has added this new dimension, anything communication to the ICT. In ICT already we were having anytime, any place connection, right? Now in this 2D spec, this third dimension has been added on with the use of this IoT, right? Now see the threat, because see with the applications, threats are also increasing, correct? So with the dimension of challenges, as I told you, are also increasing with the applications of IoT. These challenges already addressed by so many IT stakeholders, like Casper Sky we are talking about right now, and other media platform regarding its associated threats. So for IoT, the initial designs was for the private communication network, then moved to the IP network, and later on this internet came into the picture. Now, if you think about the sensors, because sensors we are used to deploying in different locations, so the firmware's updates are hard. You may say it is nearly impossible after the installation. That is the main problem with IoT security. That's why attacks are very much possible and security are easily compromised. So you may see this figure. So in 2008, Hydra came into the picture, then PySpot, T-Tsunami. Now recently this Mirai. Why this Mirai we are talking about? Because Mirai botnet emerged in 2016. The whole world learned how dangerous such device may become in the hand of cyber criminal. So basically Mirai is unlike other malware because it attack only on IoT. It doesn't work over the computer or some other thing. Only for IoT this was designed. So if you are interested, you can go and some Jha. I mean, somebody was from India who has done it. Some Jha, Prakash or somebody was there who has developed this Mirai. Then the another one was this T-Tsunami, because it was working for the DDoS, the distributed denial of service attack. I mean, it is a cybercrime in which the attacker flood a server with the internet traffic to prevent users from accessing the connected online services, right? So I mean, this bottleneck, come time to time, and it impacted badly over this IoT devices. Now, if you see this article, you understand that why this security of IoT devices are at most important. So, according to the HP report, Internet of Things Security State of Union, a total 250 security holes have been found in the tested IoT. Just think about it. On an average, 25 per device. That is the number of loophole each device, IoT device, is having. So the issues are related to the privacy, insufficient authorization, lack of transport inscription, inadequate software protection, insecure web and interface. So as per this study, 70% of most popular Internet of Things devices contain serious vulnerability. So we understand that how big, there is a huge opportunity where we can do the contribution by doing a suitable research to how to secure these IoT devices which are deployed at the endpoint, how to protect it from the cyber criminals, right? And for that regard, as I told you, this conventional encryption techniques which we have developed to protect the data over the server or computers, that is not as it is suitable for the IoT. They cannot be as it is mapped, and that cannot be reused in IoT environment. The reason being is the computational power issues, the battery devices from the cyber criminals. Now, this has happened in 2000. This article I took from 2021. So hackers break into the Florida water treatment facility, changes the chemical label, right? This is another way. It is another weapon through which we can do the war, right? If you are, if you change this, water treatment facility, if you change the reading, definitely so many people is going to be, they can damage their kidneys, or maybe some critical issues come into the picture. The entire region will be affected by this crime, right? So it is another weapon through which this war can be propagated. So again, we have to rethink about how to secure it, because as I told you, as per the Gartner, 9 billion plus devices we are right now connected. We are through which this the communication and everything is going on. So again, the concern is how to propose efficient technique through which we can protect the data. That is the utmost important thing. Now, if you see this in 2000, during the Donald Trump time, US has come up with a bill for that regard, to security bill, which was concerned with this security standard of the IoT device, right? So that is the importance of this the protection of IoT. Now, if you see this diagram, at the center of the network or the application platform, that is a data storage server, and the network and security management system. Now, this central system basically gather data by using sensors and send the control signal to the actuators, and these are actually responsible for managing the IoT device and their communication network. Now, if you see the edge of the network are the basically IoT enabled device, some of which are quite simple constrained device, and some of which are more intelligent unconstrained device. The shading, if you see the shading part in the figure, indicate the system basically that support the some of the function like IPsec, right? So here actually we are having an unconstrained device which may or may not implement some security capabilities. If you see the constrained device, we are representing it by C. It is having a limited or no security features basically. we are having a gateway that we are representing by G. So gateway device can provide the secure communication between the gateway and the device at the center, such as application platform and the management platform, right? So this is actually IoT security framework. So if you see, there is a smart object and embedded system. So basically, this smart object consists the sensors, actuators, and other embedded system at the the edge of network. This device may not be in physical secure environment. So because it is not secure environment, so I mean protecting this actuators and other smart devices from the unauthorized use, privacy protection from eavesdropping may also be the requirement. Now next to this smart object, we are having a fog network. Now this level is concerned with the wired or the wireless interaction of IoT device. The key issue of concern is wide variety of network technology and protocol used by the various IoT device and need to develop and enforce the uniform security policy. After that, we are having a core network. So this core network provides a data path between network center platform and IoT device, right? Then we are having this data center cloud. So data center are the cloud. This level basically contain the applications, the data storage, the the network management platform, right? Now the liability of the IoT. So basically, three area of concerns. We are having with this IoT. That is the first is device malfunction, data theft, and cyber attack. So device malfunction, I mean, when this IoT system fails or, the malfunctions, they can cause a substantial damage. For example, let us think about IoT furnace control system. Now, if because of the malfunction, because of the attack, let's say if it experiences the glitch, it may fail in unoccupied home and cause the frozen pipe or water damage. Number of consequences we may get if this furnace device will experience any sort of glitch. Now the next liability is data theft. So data, again, data is always is having a strength as well as having a weakness. So because of that, again, the cyber attacks come into the picture. IoT device expose the entire network and anything directly impacted to the risk of attack. So basically, some of the effective measures, again, the attacks are, we can do the encryptions, we can perform the risk analysis, we can perform the authorization, and we can do the built-in protections, right? So built-in security means individual organization should seek the hard-end devices, meaning those with the security integrated in the hardware and firmware. Then we are having an encryption. This must be implemented by the manufacturer through the user system, right? Now this IoT security and privacy requirement, that is a IPUT, that is the International Telecommunication Union Telecommunication Standardization Sector. Now the concern is, we understood the problem, right? So many issues are there with the IoTs. Now the question comes, how can consumer find secure IoT device, right? Because we have seen that so many consequences are there to use this IoT. So how consumer will assure himself either he or she should use the IoT device or not? Because they are not very expert for doing an encryption. They are not very sure how to protect the data, right? So what they are supposed to do? No need to be expert in the data encryption to properly secure their internet connected devices. So likely, any new IoT device introduced to the system will have a default setting system. I mean, whenever you purchase some this IoT devices, they are having some default settings, which may need to be changed immediately. If you are bringing the those sensors or actuators with yourself, just change change the setting immediately. That is the first thing which we used to do. And second thing, that also include the resetting of passwords, because all the devices are protected by password. They are having some default password. What we does after bringing that home, we firstly change the default password. That is another thing which all the consumer used to perform. The third step is, the third precaution which we generally take is we have to keep the software patches up to date, always connected, and always we have to assure that all the software patches which are released by the company, we have to update it out at a regular intervals, right? The another thing which comes, that is a two-factor authentication. That is a wise security precaution. Two-factor authentication require the secondary user authentication. I mean, one time, just like sometime we used to bring something, then we, just like a SBI mobile app, right? We used to get the alert message over the mobile. So once we give the code, then further the that work on, right? So that is a two-way authentication, right? So by that way also we can manage we can protect the data. So if you see this mutual authentication and authorization, this IoT user can access the IoT. So this mutual authentication and authorization between the devices and the IoT is required to be performed according to some predefined security policy, right? And you should also have a security audit. I mean, any data access or attempt to access the IoT applications, they should be very transparent, traceable, and reproducible according to the appropriate regulations and laws. So security audit should be there. I mean, it should be supported by your device, right? That is a standard. So the another things come here, how to provide the security, right? So we have talked about the standards. Now the thing is how to provide the securities. So the first common way, these are the way through which we can, provide the security. The first thing is we have to do the encryption. We have to provide the password protections, hardware security modules, two-factor authentication, as we have discussed. Am I audible? Am I audible?
Yes, sir.
Okay. So let us discuss this one by one. Encryption, as I told you, we have to use some conventional encryption cryptographic algorithm may not perform well. They perform well over the computer and server and some mobile phone, but that they are not suitable for RFID tags or sensing device or sensor network or maybe the embedded systems. So we must come up with some, the lightweight encryption technique through which we can make the, this IoT device secure. Why actually every time we are discussing about the cryptographic technique? The problem with the Moore's law, if you know about the Moore's law, so that state that processing speed of any system will double after 18 months. As a result, advance in technology and computing performance will always make a brute force attack. Brute force attack is always possible, right? Either you are developing any kind of technique, this brute force is always going to be happening. So again, one more difficulties which we are having, that is as per the Kirchhoff law, whatever encryption technique you have proposed, that encryption technique should be open to all. You can only hide the keys, but you cannot hide the protocol through which you have performed the encryption. So again, that is that thing we should always remember. You cannot say that I have encrypted data, now you will decrypt it. It's not, you will not reveal the policy which you have developed. You have to develop that policy and you have to put it into the domain. And only the key part you have to save, you can keep with yourself. So any technique will be called as secure if and only if the as per the Kirchhoff law, the algorithm is well known to everybody. Only the key part should be the hidden. Key part should be kept secret, right? If somebody cannot decrypt it, it means what? Your technique is safe and secure. But again, in all the cases, this brute force attack is always possible, because as per the Murray law, Golden Murray, every 18 months, this processing speed of system is going to be increased, right? So it means that this brute force is always going to be effective, right? So the concern is, I mean, so many aspects we are having, like in real-time domain, because we used to change the session key every time. The reason being is now we are having good server with the good processing speed. That's why sometimes you may see that some session key used to come and that is valid for only 5 minutes, 10 minutes, or 15 minutes, or 15 seconds, like that way, right? After that, it lapses, right? So that is only to provide the security, because after the session key, that again we have to rechange the session key. Server will rechange it, right? So that part we should always remember whenever we are discussing about any encryption technique. Now, we may ask, because see, as you all are knowing that we are having basically two type of encryption technique, like one is symmetric, one is asymmetric. Both are having advantage and disadvantage. Symmetric is having its own advantage, asymmetric is having its own advantage. For example, symmetric algorithm lacks in authentication, right? Authentication we cannot assure by using the symmetric encryption, whereas asymmetric suffers with the the key size, the larger key size, and the consumption of the more memory. And this thing will affect the real-time information gathering and processing if you are applying the asymmetric encryption on that, right? That's why we are discussing about some lightweight encryption techniques. Because see, if you apply the symmetric as it is having authentication issue. If you apply the asymmetric encryption algorithm or the IoT data, then again, the key size is a concern. Again, the consumption of more memory is a concern. The communication power of, because it is a resource limited device, right? They are not having a very huge computational power. That is also the concern, right? So we have to, that's why we have to rethink and we have to come up with some lightweight encryption technique. So many password protection is not very efficient actually in case of this IoT devices, because most of the devices are dumb device. So this password protection is not very influential in the terms of providing the security of IoT. This HSM we can use, this HSM we can utilize for that regard for providing the security. Now, see, for this one, I mean, number of encryption technique, number of lightweight encryption technique we are having through which we can provide the security of the IoT device. For example, we are having an algorithm like AES, hide, present, RC5, TEA, that hummingbird. Hummingbird may, number of variations, versions of hummingbirds come, hummingbird 1 and hummingbird 2, then there is iceberg, many, many more number of lightweight encryption come into the picture time to time, right? So again, I mean, the entire concern comes at the point that how to provide the safety and security of this IoT data. So as I told you, we cannot directly apply symmetric only. We cannot apply asymmetric directly because it's having their pros and cons. So we have to, we have to propose some method. I mean, that is this one, right? I mean, this very important part, if you're talking about this IoT encryption particularly, because, as I told you, symmetric and asymmetric is having their limitations. So we have to, we have to find out some suitable way through which, based on the need, we can apply the symmetric, we can apply the asymmetric, right? So that they should be the, the lightweight. That is a concern. I mean, key size, computational power, number of rounds. This should be, the limited. They should not be that much as it is, right? Because of all the devices are having a limited capabilities of computation. Now here, if you see this image, so we are having this IoT device. So all the IoT devices are having their data size, battery power, memory space, computational power. So here we have to categorize it. We have to check the threshold. If data size is more than some threshold, it means what? If it is a big data size, blindly we should go with the symmetric encryption, because for the larger data size, asymmetric is not that much suitable at that moment. we should categorize it and we should go and we stop the symmetric encryption for that regard. But again, in symmetric, as I told you, authentication is the issue. So that we have to come up with a suitable technique to mitigate that issues. Again, let's say the data size is small. Again, the another concern is battery empowered? The device is battery empowered or not? If it is yes, then we have to again check the threshold of that. If it is having a no, again, we have to come with the symmetric, or we should go with the asymmetric. Again, for the asymmetric, you will say the another condition. Condition is it is a limited memory space device or not. If it is yes, then we have to calculate the threshold. And if it is a more than threshold or less than threshold, accordingly, we have to select the symmetric or asymmetric. Again, if it is having a memory size is more than memory threshold, again we will check it is having a computational power or not. If it is having computational power, we'll check the threshold. And again, if it is more than threshold, if that condition is not satisfying, again we should apply the symmetric or we should go with the asymmetric. Likely, we have to understand that one technique is not suitable at all for all the kind of devices. We have to check their, the characteristic. Their data size, their battery power, their memory space, their computational power, and accordingly, we have to select which technique is going to be suitable and which one we should opt and which one we should ignore. So this is a very important aspect through which we can, decide which technique we should, apply and which technique we should ignore for that regard. Now the another part, I hope time is there or not. I should stop it. Or I'm still, if I'm having time, I can move on to the cryptography. Please, the organizers, shall I move ahead or we should stop here? Sir, shall I move on or I should stop somewhere here? If you allow, I will move on. So am I audible? Sir, am I audible? I think I'm not audible right now. Sir, shall I keep? Sir, Gulfam sir.
हेलो सर, मनोज सर, कैसे हैं सर? ठीक हैं?
बढ़िया 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 सर, बहुत अच्छे हैं।
ओके,
आप कैसे हैं सर?
अल्हम्दुलिल्लाह मैं ठीक हूँ सर, आप बताइए।
सब बढ़िया। आप अगर अलाउ करें तो हम आगे बढ़ें, अदरवाइज टाइम अगर ना हो तो आई विल स्टॉप हियर।
नहीं सर, अगर आप खींचना चाहे तो कर सकते हैं, अभी टाइम है हमारे पास, क्योंकि हमारा जो सेकंड सेशन शुरू होता है वो तकरीबन 2:30 पे होता है आफ्टर लंच।
ओके सर, so if you allow I will continue, otherwise I will stop here sir.
As you wish sir.
Okay, no, because if already I hope the esteemed speakers they have discussed this cryptography part, so I don't think again I should discuss this. So I can go on the last phase, that is the image and video data, how to provide the encryption of image and video data. So with your permission sir, I will take another 15 minutes. So I will only show the how to protect the image and video data, how to encrypt those data particularly. So I'm skipping this. Let us encryption part, I hope everybody is knowing. Most of the speaker has discussed that. So DES and AES algorithm, actually in AES basically it is important because I have used this AES for encrypting the video data. That's why I'm discussing it. I hope they are knowing the basic characteristic of this AES algorithm. The basic, the importance of this AES advanced encryption standards is you can make your own key. Number of key from a single key, you can make a number of keys, and that key you can use for doing the cascading encryption or hierarchical encryptions, so that you can utilize. So if you see this AES, let's say I'm talking about one frame, one image frame, or maybe video frame I'm talking about. From this one frame, I have taken as a key. From this key, we can develop a number of keys. So that is the beauty of AES key expansion. So by using this key expansion, you may come up with the number of keys, and that key you can utilize for doing, as I told you, for the cascading, or maybe the hybrid, or maybe the hierarchical encryption that you can perform by that. So see how this AES key expansion works. I'm having one frame. From this frame, I'm developing the 3 different number of frames. So for that regard, we are having this approach, how this number of keys we can develop. So this is the algorithm through which we can develop a number of frames. This is how it will work, right? This is how this key expansion algorithm will work, and through which we can generate a number of keys by a given key. Now triple DES, because as I told you, with the increasing power of computation, this DES was challenged. So this 3DES, 2DES come into the picture. So in 3DES, we are using actually 3 keys. 2DES, we are using 2 keys. So what happens over there? Firstly, we encrypt. We will apply the DES algorithm over the data by using K1. Whatever cipher we used to get, that cipher will decrypt by K2, some other key K2. Then again, whatever the value we will get, again we will encrypt it by K1. That is a 2 DES. The reverse of K, if you apply the K3 in the last phase, that is a 3 DES. That is a similarity between 2 DES and 3 DES. RSA algorithm is well known, so I'm not going to discuss about it. Now, this is an important phase, the key exchange idea. Because if you talk about this symmetric encryption, both the parties are negotiate the key. Both the parties should have a same key. How the same key will go through the public channel? Because we are saying that public channel, it can be compromised, right? So if it is a compromise, then how the key should reach to the receiver, internet user? How to negotiate that key with each other? By using the public channel. That is a concern. And where this Diffie-Hellman key exchange protocol works. So I'm not discussing this protocol because it is having some numerical data. So better let us understand this by using some image diagram. So if you see this, I mean, both the parties actually will agreed upon on a common color, that is a yellow color, right? So what happened here is, I mean, here, let's imagine that we are having a 2-party. It is analogous to cryptography. I have taken the name as Alice and Bob. So this Alice and Bob both have agreed on some random color to start with. Let's say this color is that is a common paint is yellow, right? Now both of them are having their 2 secret key. One is some orange, and another one is having some greenish value. Now, by putting both together, they are getting some, some outcome. Alice is getting some random outcome. Bob is getting some random outcome. So what they are doing over the public channel, this random values they are exchanging with each other. Now, the difficulty of this algorithm is depend on that the separation of, the mixture separation is very expensive, right? The entire algorithm will depend on this only. If this separation is possible, means it is a breakable, right? So this entire algorithm will depend with the assumptions that this colored separation is not feasible or possible, or it is very expensive. So by that assumptions, the mixtures we are sharing with both the parties are sharing with each other. Once they share these mixtures, now they are using their secret color with each other, and as the result, they are getting this common secret. That is a common key which they have negotiated between each other. So this is how your Diffie-Hellman key exchange protocol basically works, and it's very famous because if you talk about this symmetric encryption, the keys are important. The key should be shared between both the parties, right? So this is how we can do it. Now the another concern comes here, that is if you will talk about this one, sorry, I mean, I forget to discuss this part. This is the main issues actually. If you talk about the symmetric encryption, then if it is having 2 parties, then definitely 1 keys are important. If it is a 3-party, then there is a requirement of 3 key. If it is a 4-party, then 6 keys are important. If it is a 5-party, then 10 keys we are supposed to share. We are supposed to share with each other 10 keys. Let's imagine about 100 people. Let's imagine about 1,000 people, because it's a if you talk about the conferencing, then number of people are there, right? So how to send and receive the data, we have to develop some key. Then this approach is not that much suitable in that case. The key exchange idea is not that much suitable. And as I told you, I mean, for for doing this, number of keys we are supposed to develop, right? If it is a 5 parties, 10 keys. If it is a n party, p multiplied by p minus 1 divided by 2, that means number of keys are important. So to overcome this problem, actually, we are having this group Diffie-Hellman protocol. Group Diffie-Hellman protocol. So here, all the parties who want to do the conferencing, they comes together, and with the help of the trusted party, I mean, through each other, they agreed upon some common key. And this is the process how this happens. So all the persons who want to come into for the conferencing, they develop the nonce, they take their nonce N1, N2, N3, N4. Let's say 4 parties are there, P1, P2, P3, P4. All the ones are having their nonce. And by this way, they start the, developing a common key. P1 send G to the power N1 to P2, P2 send G to the power N1 and G to the power N1 N2 to P2. And this process will keep going. And then what happens? P2, P3 send G to the power N4, N3, G to the power N1, N4, N3 to the P2. Now P2 will use his own private key and he will get back the common secret. By this way, all the parties will be shared the same common key. And now they will use the same common key for doing the video conferencing or, this communication they can establish, because every one of them are having a same key with each other. They can utilize the same key for doing the for securing the data. Now concern comes, if somebody new joining will come, then again this protocol will rerun. Or somebody is leaving the conferencing, again we have to rerun the same protocol over the existing users. And again, they will come up and develop the same common key. And by that way, they can perform the encryption. Now, as I told you, these are the famous lightweight cryptographic algorithm for IoT, AES, RC5, TEA, Present, Hummingbird, Iceberg, number of techniques we are having through which we can perform this encryptions. Asymmetric, we are having a RSA ACC. Now this aspect, as I told you, error detection. Now there is a fourth part of my presentation, that is a error detection and correction. Let's say receiver is receiving some information. How he will understand that the received data which he has received, that is erroneous or error free. So basically we are having this kind of error. Basically this 3 type of error we used to encounter with a single type of single bit error, multiple bit error, or burst error we may have. So how receiver will understand that the data which the erroneous or not? For that regard, number of methods we are having for detecting the errors. Like we have to actually, to understand it, we have to add some parity bit, some redundant bit we have to add the sender side. And that with the message and the redundant bit we used to send over the public channel. Now receiver will again regenerate that redundant bit and check it out that it is same or not, and accordingly they will accept. They will understand that the data which he is receiving, that is erroneous or error free. So sometime we are having a method which is suitable for the single bit error, but over the public channel definitely the burst errors are always possible, right? So number of techniques we are having through which we can do it. So first one is the this one, redundancy. So what basically happened, we are having a data. Through this, we apply the generating function and it will give you the redundancy check. Now what happened? Now this data and the redundancy check we used to send over the public channel. Now what the receiver does, again by using this data, he will regenerate this redundancy bit and it will check it out. Either we should accept it or we should, if it is a same, means the data has not been changed. If it is a change, it means data has been changed due to the transmission. So one way is you reject this packet and again ask for the resend, right? I mean, resend the, you will send the acknowledgement to the sender that resend the entire package. The entire package again come to you. Or if you detect, you will abort the data. Or you are having a detection. If you are knowing the correction technique, you will correct it. If it's a single bit error, that we can do. So the famous one is this one. I mean, 4 techniques, number of techniques we are having, so that I'm not covering all together. VRS, LRS, CRC checks, and there's a fundamental one. So I will not discuss this. I will discuss that cycle redundancy check first. So that is important. So I mean, this CRC basically we use to check it out that the data which we are getting, that is the erroneous or not. So here what we do is we are having a data, we are having a devices. Some cyclic group, some devices, we are having some famous devices I will show you. So if it is having n plus 1 bit, so n bit zeros we have to add with the data. And again, we have to divide this entire thing with this divisor. Whatever we will get at the end, that CRC, that was CRC. So what we does, this CRC we have to append with this data, and this entire packet we have to send to the receiver. What receiver does, he will again do the same thing. By using the divisor, again, he will divide the entire thing and will check the remainder. If the remainder is 0, it means what? It is accepted. If it is non-zero, means what? Some data bit has been changed during the communication, and by that way, he can detect the error. Detection can be done by using this. And if it is a non-zero, means what? The erroneous value we are getting here. It means we should again ask for the resummation of the data. So that is the idea of how this, it is a binary division basically we perform over the sender side. This is the data. Now, divisor is having a 4-bit, so 3-bit 0 we used to apply over here. Now, it is simple division method, binary division method. So at the end, we are getting this one as a remainder. So whatever remainder we are getting, that remainder we have to append, that we have to substitute over this 3-bit. So now this data we have to send, I mean, this data bit with this remainder we have to send to the receiver side. Receiver will also perform the same thing. If he will get 0, it means what? Message is accepted, means data has not been changed. If it is a non-zero, it means some data bit has been changed, right? So these are the some famous polynomial. If it is a, I mean, through which we have to divide this entire data. So, I mean, through the binary, we have to represent it like this. These are the famous standard polynomials which we use for performing this CRC. Now, this is a checksum, so I'm not discussing it. Let us discuss the error correction, because detection part, you understand that if something is receiving the receiver, how receiver will understand that the data. Am I audible?
Yes, sir. Audible.
Sorry, I have here power. Sorry, here we are facing the problem of power cut. So that's why I have disconnected from the internet. Am I audible now? Hello?
Yes, sir.
Am I audible?
Yes, sir. Yes,
Sir,
sir.
shall I stop here, sir, with your permission? Because here there is no power.
Yes, sir. Yes, sir. Now it's the time to take a break. Hanifa Aslam.
Yes, sir.
Okay.
Sorry.
Okay, I think that this is a network problem and it's a time to take a break for the lunch. Okay, now thank you, sir, to spare some time
Yes, sir,
and
sir.
share the valuable information with us. Participants, if anybody
Thank you,
wants
thank
to
you,
ask
sir,
any
thank
query or questions, then discuss. Now Manoj sir is among us. Participants, please, if anybody else want to discuss any problem or issues. I think that there is no question from the participants. Now, Hanifa Aslam,
Yes, sir.
it's a time to take
Thank
a
you.
break.
Yes, sir. Now the time to take a break. The next session will start at 2:30.
Thank you, sir. Thank you very much for giving me the chance to interact with such an enlightened participant. Thank you very much, sir.
Thank you, sir.
Dr. Khalil Ahmed, have you joined?
Yes, sir. Gulfam, sir.
Okay. I will make you. Sir, now you are co-host. Khalil sir, now you are co-host.
Yes, sir. Gulfam, sir.
Yes, sir.
Please, sir, start.
Adina,
Yes, sir.
let's introduce the resource person.
Yes, sir. Good afternoon and a very warm welcome to all of you. I am Adina from IMCA 7th semester Computer Science Department. I am honored to introduce our second speaker, Dr. Khalil Ahmed, sir. Dr. Khalil Ahmed is currently working as the assistant professor in the Department of Computer Science and Information Technology at Maulana Azad National University, Hyderabad. He has more than 9 years of teaching experience and research experience. He worked as the visiting SERB International Research Fellow in the Department of Computer Science, University of Italy under the SERB International Research. He visited the National Defense University of Malaysia as a visiting faculty. He received the UGC MANUU National Travel Grant in 2014. He has received the Best Paper Award at 2 conferences in Malaysia and India. He has supervised 2 PhD students, 7 MTech students, and several BTech students among with many MCA research projects. His research areas are blockchain technology, cybersecurity, cryptography, and networks. He has filed 2 patents from Malaysia in collaboration with National Defense University of Malaysia. He has published more than 50 papers in referred journals and conferences and 15 book chapters. He is a life member of various international and national research societies. In addition, he is an associate with many international research organizations as the editorial board member and receiver. So please give a warm welcome to Dr. Khalil Ahmed, sir.
Thank you, ma'am, for introducing me.
Thanks.
Thank you, Gulfam, sir, for inviting me for a guest lecture. Shall I start, sir?
Yes, you can.
Okay, thank you, sir. Gulfam, sir, is my screen visible?
Not yet.
Okay. Sir, now is it visible?
Yes, sir. Now visible.
Okay, sir.
Please put it in the full screen mode.
Okay, sir. Now is it okay?
It's okay now.
Okay, sir. Thank you, sir. Yeah, I'm going to deliver my talk on role of blockchain technology in digital era. We are moving from paper to paperless. Digital, we are trying to make the digital India. Role of technology in digital transformation. Actually, digital transformation is the integration of the digital technology into all areas of the business, fundamentally changing how you operate and deliver values to customers. It helps an organization keep up with emerging customer demands and therefore survive in the face of the future. It allows companies to compete better in an economic environment that is constantly changing in response to technology evolutions. Actually, it is a cultural change. Okay, as we are moving from paper to paperless, same we are every day we are changing the technology. We are adopting the new technology. It is a great challenge for the software companies. Okay, it is actually it is a cultural change, nothing else, that requires organizations to continually challenge the status quo, experiment, and get comfortable with failure. It is one of the component of the company. Your product may be fail, always not successful. Now, now we are using as I earlier, we are moving from paper to paperless. Okay, in the same case, we are changing the technology. We are moving from old technology to the new technology. Right now, we are using the centralized system, centralized technology. Okay, that is a server base, but we are trying to move on the DLT, distributed ledger technology. Okay, actually, blockchain technology is based on the DLT. It is the main component of the blockchain technology. Blockchain is a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system. A blockchain is essentially a digital ledger of transaction that is distributed across the entire network. Okay, because blockchain works on the peer-to-peer network. Okay, all the peers have the same equipotent and the same rights. These are the properties of the DLT. It is programmable. Okay, secure, anonymous. The identity of all participants is anonymous. Okay, and the main property of the blockchain is the unanimous. Means all the participants are then the smart contract will be executed. Okay. Next component is the time stamp. Okay, transaction stamp is recorded on a block when it was happened. Okay, it shows the actually it shows the when transaction is created. Okay, and the next property is the immutable. Any validity records are reversible and cannot be changed. Yes, once the information has been saved in the blocks, it cannot be changed. Okay. Next property is the distributed. Okay, all the network participants have a copy of the ledger for a complete transparency. Okay, for example, five participants in one network means all the participants have the same copy of the blockchain. A blockchain is a distributed technology and incredibly popular nowadays. It is a tempered proof technology. It saves the transaction data permanently in a distributed ledger with an immutable time-stamp series record of data, and it is built on the idea of peer-to-peer network. Okay. It can and the blockchain technology can be implemented in public, private, and the consortium mode. Actually, there are three types of the blockchain: public, private, and the consortium mode. And this innovation is widely used in various fields of the industrial revolutions 4.0, such as government sector, supply chain, healthcare, Internet of Things, real estates, and other fields. The blockchain provides approaches and solutions that cater to the business demands oriented to the fourth industrial revolution. When we had the blockchain, then we understand it is a Bitcoin. No, blockchain is not a Bitcoin. Actually, Bitcoin is an application of the blockchain. Okay, Bitcoin is a application of the blockchain. Actually, Bitcoin is the first application of the blockchain. Who created the Bitcoin? Satoshi Nakamoto. Who's Satoshi Nakamoto? Still is a mystery. Nobody knows who's Satoshi Nakamoto. Many people claim that I am Satoshi Nakamoto. Okay, but it has not been clear that who's actual owner of the or creator of the Bitcoin. In the 2009, Satoshi Nakamoto created the one cryptocurrency, but right now the more than 7,000 cryptocurrencies are available, like a Bitcoin, Litecoin, Monero. So I show you the few currencies name. These are the few currencies: Bitcoin, Ethereum, XRP, Ether. These are the actually application of the blockchain. Okay, blockchain is equal to Bitcoin? No, it is not. Both are not equal. Actually, Bitcoin, you can say all cryptocurrencies are application of the blockchain. Yes, you can see here. Yes, a few quotations. Patrick Byrne said, "The blockchain revolution has a greater potential than anything we have seen in history. It's bigger than the internet revolution, how it is going to restructure society." Okay, this is said by the Patrick Byrne. Okay, Don Tapscott said, "The technology likely to have the greatest impact on the next few decades has arrived. And it is not a social media, it is not a big data, it is not artificial intelligence, it is not a robotics." Okay, you will be surprised to learn that it is the underlying technology of digital currencies like Bitcoin. It is called blockchain. Okay, we call all the cryptocurrencies, we call it also digital currencies. Many countries try to develop the cities based on the blockchain. Okay, but Dubai became the first smart city in the world fully powered by the blockchain technology in 2020. It was actually a dream of the Mohammed bin Rashid Al Maktoum. Okay. Right now, the Dubai is the fully powered by the blockchain technology. It is the first city in the world. I give another example of the blockchain technology. As we know, we watch the many videos or movies on the YouTube. It actually YouTube works like a YouTube. YouTube developed based on the centralized system. Okay, but DTube develops based on the decentralized system. Okay, DLT, DLT, distributed ledger technology. Okay, they use the blockchain technology concept. You can watch the videos, you can upload your videos, you can open your account. Okay, you will get the reward as you get on the YouTube channel. Only technology different, nothing else. This is the another social media applications, Stream IT. It works like a Facebook. Okay. It is another application. It is developed based on the blockchain technology. Everyone knows Uber, Ola. Okay, they use the centralized system, but the Lazuz, Lazuz is the first, first booking vehicle booking website. It is developed based on the blockchain technology. We can also apply the blockchain technology on the elections. It is a major issue for any country to conduct elections. Okay, suppose you are from India, or maybe you are from a particular state. If you are not available, or if you are not present in your state, then you cannot cast your vote. You have to you will have to go in your state or your concerned place, and then you can cast your vote. But if you are a citizen of India, you can cast your vote from anywhere with certain conditions. For example, if your age, suppose minimum age is the 18 years, then if you are 18 years old, then you are eligible to cast your vote. Okay. From any locations, any geographical locations, you can cast your vote. We can use we can also use the blockchain technology in elections. Yes, recently Ford and BMW car created a consortium network. After manufacturing the car, all the cars will be registered on the consortium MOBI blockchain network. Okay, MOBI means Mobility Open Blockchain Initiative. Okay, it is actually consortium. It is made by the two companies, BMW and the Ford. Okay, suppose you buy the car from any companies, for example BMW, then your all the information will be stored on the consortium network. Okay, even you go give your car to the service, then your all information will be saved on the consortium network. Even you cannot cheat. Your all activities are stored on the consortium network. Okay, they will create a one birth certificate, VID, vehicle identification first, VID. Okay, if you sell your car, then you can easily identify the situation. Okay, so there is no modified in the car. Okay, suppose you run the car 5,000, 1 lakh kilometer. You can change the meter. No, you cannot change. Okay, suppose you missed your service of your car, all the information are stored. Okay, suppose you sell the car to other person. Okay, then another VID, means vehicle identification second, will be created. Okay, now who is the actual owner right now? Right. So it is easily we can track the status of our car. You cannot do the cheating. These are the more than 50 plus blockchain real world use cases where the blockchain used. Yes. Now, what is the basic foundation of the blockchain? Actually, BCT. Blockchain is built on the distributed computing, software engineering, cryptography, and the game theory. Okay. The next question is the why do we need the blockchain? Yes, blockchain we need. And these are the few reasons. For example, faster settlement, security, immutable, transparent. Transparent means all the participants can see the status. No need to the third party. All stakeholders of the network can participate in the network, thus ensure the transparency. Actually, blockchain, all blocks are connected. Connected each other cryptographically. Okay. A blockchain is a distributed ledger which has a shared database based on the consensus algorithm. Okay. Before adding the block on the blockchain, first it will be mined. This is the main component of the or main pillar of the blockchain technology. This is the key point of the blockchain, mining. I will discuss the mining in the next slide, in the upcoming slides. These are the 5 basic pillars of the blockchain technology. First, consensus protocol. Just I said to you, is the main component of the blockchain consensus protocol, or you can say mining. It is a part, actually consensus protocol is a part of the mining. Next component has cryptography. Next, immutable ledger and peer-to-peer distributed peer-to-peer network. These are the 5 basic pillars of the blockchain. Now we will discuss the one by one. First one is the distributed peer-to-peer network. Okay. Distributed means a global network of computers work together to keep the blockchain secure, correct, and the consistent. In peer-to-peer network, yes, in peer-to-peer network, all the participants, all the peers are equally privileged, equipotent in the application. Okay. For example, ledger. What is a ledger? Ledger actually is a collection of the financial account transactions. For example, Kim sent the $30 to Joy. Kevin sent the $80 to Jan. Actually, this information will be stored in the ledger. Okay. Fine. Sorry. Okay. This information will be saved into the block, and after the transaction, after the process, the block will be shared in the network, peer-to-peer network. Every participant will receive the copy of the block, or you can say ledger, right? Yes. You can see here, means all the peers have the same copy of the blockchain, right? BitTorrent is the best example of the peer-to-peer network. Actually, I think so everyone knows who are computer background. BitTorrent, okay, it works on the peer-to-peer network, but that is not developed based on the blockchain technology. Only it used the one component of the blockchain, that is the peer-to-peer network. That's why we say BitTorrent is not safe. Next component is the hash cryptography. Hash. For example, every human has a unique identification. Thumb is the unique identification of every human or of every person. Okay, it cannot be thumb impression cannot be matched with the other person. Different people have the different fingerprints, or fingerprint is a unique identifier of a person. Okay, according to the research, there is a possibility that the thumb impression of one person may be matched with any one person out of the 60 million people. There is a possibility. It can be matched. It is not sure. Okay, but possibility. What is the possibility? thumb impression of one person may be matched with any one person out of the 60 million people. Okay? So it means there may be chance. Now, I try to explain in context of the hash cryptography. Okay, this is actually hash. Okay, hash actually is a bunch of random numbers of the random numbers and letters. Okay, this is actually hexadecimal values, or hexadecimals is a combination of the numbers and letters. Okay, we also call it the digital fingerprint of data. This is the digital fingerprint of data, right? It cannot be matched. The hash value of one data with another data. It cannot be matched. It will be unique. Okay. So I give the one example. The hash. Okay. For example, I write the workshop. First letter is small, sorry, capital. Okay. Now I copy the hash value of this data. Okay. I paste here, and then just I write it W in the small. Okay, all the letters in a small. Now I change the hash value of this data. Now please have a look at here. It is not a little bit changes in the hash value. It is entirely changed. If you do the minutely changes, it will give the measured changes in the hash value. It will be completely changes. Okay. So has a fixed length. For example, if you are using the SHA 256, it will give the output in the 64 bit. Okay. Different data always map to a different hash value. It is a one-way function. You cannot generate the data from the hash value. So that's why we call it the one-way function. Okay, it is infeasible to convert hash to data. Yeah. If a small change in data leads to a large change in the hash value, just I just explain the practically. Okay. As I explained here, there is a possibility of a one person maybe match the fingerprint with any one person out of the 60 million people. But in case of the hash value, there is no possibility of hash value will be same. Even data in millions, trillions. Okay, it means it is more secure than the thumb impression. This is the structure of the block. Okay. This is the block hash value. Actually, block hash value is the previous hash. For example, it is a block n. Yeah, this is the block n, and the previous block is the n-1, and the next block is the block n+1. Okay, these are the few few parameters of the block header. Nonce value. Nonce means number used has, previous has, timestamp. Okay, Merkle root, block number. Okay, and the version number. Version number means software version number. This is the transaction counter. It will count the transactions, how many transactions are stored in the block. Okay, this is that's why its name is transaction counter. Okay, and all the transactions will be saved in the Merkle root. Okay, and the hash value of the block n will be saved in the n+1. Okay, and the value of the block n+1 will be saved in the block n+2. Or all the blocks are cryptographically linked. Okay. Next, this is the blockchain structure, right? Have a look at here. This is the first. I mean, first is the engine of the train, and the next are the blocks. Okay, bogie of the train. Okay, genesis block. Actually, what does mean of the train? A train engine. Engine shows that train engine. I mean, tell us that the train start from this point. Okay, this the only one point is open and one point is the close. Okay, so same concept came in the blockchain technology. Genesis block. What does mean of the genesis block? Genesis block shows that the blockchain starts from this block number. Okay, and the genesis block is the hard coded block. Okay, this is developed by the software developer. Okay, security purpose bring the concept of the genesis block, because the one side is open and one side is closed, because all the blocks will be add from one point, from from one point only, or from one end only, right? Previous hash, there is no previous hash, because this is the starting block, right? This is the hash value of this block. Okay? Right. This is the next block. This is the next block, block 2, and the previous hash is the previous hash means genesis block hash value. Okay, and the hash value of block 2 will be stored in the block 2. And so that's below all blocks are cryptographically linked together. And the mutation effect. Suppose if you do the some changes at any block, okay, and at any block, the all subsequent blocks will be invalid. Why all subsequent blocks will be invalid? Okay, there's a reason. I tell you. This is the actually hash value of block 2, actually, right? And this hash value is stored in the block 3, right? 4DF6F05, right? Suppose if you a hacker some changes in the block 2, then the new hash value will be generated. Okay, but the original value is stored in the block 3, then it will be compared. So then it will show an error. There is something is wrong in the block 2. Okay, fine. And the block 3 original hash value is stored in the block 4. And okay, then again block 3 will be also a red. Okay, it will flash some error. Okay? In the same way, all the subsequent blocks will be invalid and flash a error. There is something is happened wrong, right? Okay, for example, you buy a car, okay, and your information is stored in the traditional database. Okay, a hacker can change your information and can claim it's my car. Okay, because a hacker can a hacker has changed the information, okay, in the transport database. Okay, right now you are not a actual owner of this car. Okay, it can easily claim, but if the transport use the blockchain technology, a hacker cannot claim it is my car. Okay, for example, so many frauds are going on in the field of the property. A property dealer sell one property to many people, so it is very difficult to track the property who is the actual owner. Okay, so if they use the blockchain technology, then it will be very difficult to change the information. Okay, already I explained in the previous slide, if you do the some changes at any block, and all the subsequent blocks will be invalid, like this. Okay. Next component is the consensus protocol. We also call it the consensus algorithm or consensus mechanism. Consensus means agreement. All the parties are agree. Okay. Actually, consensus algorithm achieve reliability in the blockchain network and establish trust between unknown peers in a distributed computing environment. Okay. The consensus protocol makes sure that every new block that is added to the blockchain is the one and only one version of the truth that is agreed upon by all the nodes or all the participants in the blockchain. Okay. These are the few I mentioned here the few consensus protocols. For example, proof of work, it is very famous. Everyone knows the proof of work. Actually, it is used in the Bitcoin currency. Next is the protocol is the proof of stake, Byzantine fault tolerance, and delegated proof of stake. These are all the consensus protocols. But right now, the two protocols are very famous: proof of work and the proof of stake. Right. So now we will discuss the proof of work and the proof of stake. Yes, proof of work. A solution that is difficult to find, but it is easy to verify. Okay, a solution that is difficult to find but easy to verify. This is the principle of the proof of work. It was created by it was introduced by the Cynthia Tor and the Moni Noor in 1992, and later used by Beck A in 2002 to reduce the number of spam emails. Okay, but 2008 used by the Satoshi Nakamoto in the Bitcoin and Bitcoin currency. Okay. These are the diagram of the proof of work. How does it work? I try to explain. These are the headers of the block, as I discussed earlier. Merkle root, timestamp, previous block has version number, and another nonce value. That is the important nonce value, number used once. Okay, and adjust the nonce value. Okay, create a block header, right? Then we'll apply the SHA-256 algorithm. Okay, generally Bitcoin and Litecoin and few cryptocurrencies are using the SHA-256, but other cryptocurrencies are using the on hashing algorithm. It is not universal that all the cryptocurrencies are using the SHA-256. No. Okay, right. Then you apply the SHA-256 algorithm, then you will get some hash value. Okay, and then you check the block hash value is the target value. You actually will set the target value. Okay, what is the target value? I will explain you. If the target value, if the block hash value is less than the target value, means it is true, right? It means you solved the puzzle. It will be added in the blockchain. Okay, if not, okay, if the block hash is not less than the target, it is not less than target value, again you change the nonce value, then again calculate the hash value. Okay, until unless you do not get the target, you do not get the block hash value less than the target. Okay, you try to solve the puzzle. Just to explain you. Right, I think is it visible? Right. This is a diagram of the proof of work. This is the block header. Okay. And this is the nonce value. You calculate the hash value of the block. Okay. Proposed new block. Okay. You calculate the hash value. If the hash value less than the target value, then okay. Yes. No. Then increment the nonce value. Then is solved. Okay. What is the formula of this to solve the puzzle? Let you. This is the formula actually. New proof square minus previous proof square is the actually formula. Previous proof means previous proof. Okay. New proof you have to start from the zero to until you do not get the hash value. What is the hash value? That is the hash value of the block that is less than the target value. Just I explain the diagram. This is actually target value. Okay, fine. How to set the target value? Okay, this actually you will get the output in the 64-bit. Okay, because SHA 256 give the output in the 64-bit. You keep the ending values view 0 0. Okay, if we call it the difficulty level. Okay, if you increase the difficulty level, okay, the mining will be very difficult. It requires a more computational power. Okay. Right. For example, I calculated the block hash value of block 2. Okay, for example, I set the difficulty level 3. Okay, and the remaining is the 61 FFFF. Okay, this is the maximum value. Okay, this is the target value. I set it, and okay, I will mine the block 2. Okay, so how will I mine the block 2? Is the previous proof from where from I will get the previous proof value from the Genesis block. Actually, this is the Genesis block. This is the hard-coded block. Okay, no need to mining it. It is by default block in the blockchain. Okay, this is the previous proof, right? Okay, fine. Previous proof 1 square, right? New proof. Now you have to start from the 0 square minus 1 square, 1 square, 2 square, until you have to again change it 0 1 2 3 4 5 6 7 until you do not get the hash value less than the target value. Okay, right. So means you will get the block hash value at 533. Okay, now the condition is true. This is the hash value. Okay, I just show you here. This is the hash value which I calculated, right? And this is the target value which I set, right? I set here. This is a target value, right? Now see here. This is the calculated value. Calculated value of the block is less than the target value. Now the condition is true. Now this block is has been mined. Now block will be added in the blockchain. Okay. For example, I take you the another case. Suppose I have to mine the block 3. Fine. Then the same formula will be applied here. Previous proof square minus new proof square. Okay. Right. What is the previous proof? Means suppose we are mining the block 3. Right. What is the previous proof? Block 2. You go to the block 2. What is the previous proof? Block 2, 533. Right. I put here 533. Right. Now again you start from the 0 1 2 3 4 5 6 7 until you do not get the block hash value less than the target value. Right. We got the block hash value which is less than the target value at 11,028. Okay. Now the condition is the true. Again you compare it. This is the calculated value I sold here. Okay, and this is the target value. Okay, fine. In the same, if you increase the difficulty level, then it will be more difficult and it requires a more computational power. Okay, just I calculated the calculated up to 6 only, because it is the maximum computational power of my system. I cannot put more than the 6. Okay, more than 60. Okay, my computer cannot mine, right? This is actually mathematical, right? I come back to my PPT. This is the explanation of the proof of work, how to solve the puzzles. As I actually, this is the principle of the proof of work: a solution that is difficult to find but easy to verify. So it is very easy to verify. How to verify? Your block hash value should be less than the target value. So it is very easy to verify it. Yeah. But are few drawbacks of this algorithm. Actually, it consumes the lots of energy. Okay, it requires a high performance hardware resources used for brute force the nonce value. In 2017, the Bitcoin mining used around 30.14 terawatt hours of energy, which is equivalent to the energy usage of the entire island in a year. Consumes lots of energy. The annual energy consumption as of 22 June 2019 is 67.937 terawatt hour. This is this increasing amount of energy consumption is affecting the environment with increasing global warming. Okay, it also obviously it consume the energy. So obviously it will produce the carbon dioxide. The annual carbon dioxide emissions by the Bitcoin network using the proof of work are as high as 22.9 million metric tons, almost equivalent to the amount produced by the countries such as Sri Lanka and Jordan. These are the drawbacks of the proof of work. Okay, many cryptocurrencies use this algorithm. Bitcoin, Litecoin, the Dogecoin. Next, next algorithm is the proof of stake. Okay, right. Now all those cryptocurrencies are using the proof of work. Now they have been shifted on the proof of stake because it consumes the very less energy. Okay, how does it work? Actually, in the proof of stake, mining is not fun. Okay, anybody cannot mine the block. Okay, the structure of the proof of stake is the different. Okay, proof of stake, who has the more stakes, okay, more stakeholders, only that person can mine. Okay, so in case of the proof work, for example, 1000 miners, okay, but only one miner, okay, 1000 miner. So means all 1000 consume the lots of energy, right? But in case of the proof of stake, who has the more stake, right? Rather than the computational power, it okay, that miner will mine the block. So it is so that's why it consumes very less energy. The concept of the proof of stake is very different. So I will not explain it more. So I have explained the mining a block. Just yeah. Mining rewards for successfully completing or means completing a one block. Okay, actually mining reward halves halves after a 4 years. In the 2009, the Bitcoin reward was 50 Bitcoin. Okay, as I told, actually after every 4 years. Okay, after every 4 years, it is half. Okay, in the 2012 it was 25 Bitcoin. 2016 it was 12.5, and 2020, okay, 6.25. Right now is 6.25 is going on. In the I think 24, it will be 3.12. It will be half of the 6.25. Okay, after every 4 years it is half. And this is the transaction flow in the blockchain. Okay. Already I have discussed the blockchain and blockchain structure, block structure. Okay, just I try to the in one diagram. Okay, all the suppose this is the user. Okay, this is the transaction data. Then hash value will be calculated. This is the digital signature. Okay, using the private key of the user. Right. This is the actually transaction proposal. Right. And it will be it will goes in the transaction pool. Okay, it will be verified. Okay, transaction validation. Right. Who will verify? Validators will verify it. Okay, then there are actually two pools: unverified transactions and the verified transactions pool. Okay, then after the verification, it will goes to the pool of the valid transactions. Okay, right. So means miners will pick the transactions from the verified pool. Okay, and all the transactions will be stored in the block. Okay, and the hash value of the transaction will be stored in the Merkle root. Okay, then it will be saved in the block. Right. Okay, after the mining, it will be saved in the blockchain. Right. Actually, if you are a miner, then you need a high configuration high configuration system. It requires a high computational power. Okay, normal system will not power. I just took a picture from the eBay. Okay, for the GPU cryptocurrency GPU mining, rig 3 GTX 1080 can be used for the Ethereum, Zcash, Bitcoin, or other cryptocurrencies. This is the cost of the rigs, $5,599. It is very costly. Okay. These are the few pictures of the rigs. This is the mining center in the China. Bitcoin mining center. This is the internal view of the Bitcoin center. Yeah. Now I have discussed all the main components or main pillars of the blockchain technology. Okay. Latest transactions. Okay. This actually I took the picture from the blockchain.com. Here it is showing the height. Height means block number. Okay. When it mined, it is showing the minutes. Okay, timing. Who is the miner and what is the size? Who is the miner of this block and unpooled? Okay. These are the here it is showing the transactions, right? Next component is the next is the 51% attack. This is the hypothetical attack. It is not actual possible. Gulfam sir, how much time is remaining?
5 to 10 minutes, sir.
5 to 10 minutes is remaining. Okay, sir. 51% attack. Okay. If a participant has more than 51% of the network, he could outmine the network and back the blockchain. Okay. It means, for example, eight nodes in one network. Okay. Okay. Suppose a hacker wants to do some changes in the blockchain. Okay. He will change in the five nodes blockchain. Okay, because he has to change in the 51% node 50% node blockchains. What is the 51% of the 51% of the 8 node? More than 4. Okay, just I give a example in the layman term. For example, in one class 30 students. Okay, 2 students are participating in the CR elections. Okay, two contestants, CR1 and the CR2. Okay, and 30 students in one class. Okay, then anyone CR is required a 16 votes for winning the contest. Okay, that is the 51%. Okay, in the same case, if you are doing some changes in the blockchain, then you have to change the blockchain of the 51% node of the network. But it is hypothetical. It is not actual possible. For example, as I read on the blog. Okay. I mean, peer-to-peer network, more than 25 million users are on live available. Okay, so the 51% of the 25 million is not possible actually to change the to hack the system. Okay, so it is hypothetical. If the size of the network is large, then it is very difficult. Okay, but if the size of your network is very small, then it will be very easily. And for the security purpose, the size of the network should be large. Next is the transactions and UTXO. Okay, what is the UTXO? Unspent transaction outputs. Okay. For example, Mark send me 0.1 BTC, Hedlin send me 0.3 BTC, Helen and Suzanne send me 7 BTC, right? These are the balance in my account. Okay, or you can say these are the UTXO, unspent transaction output. I want to buy a bicycle, okay, for 0.5 BTC, right? But that is not exactly 0.5 BTC in my wallet. Then I'll give the 0.6 BTC, okay, to the shopkeeper, right? Shopkeeper will keep the 0.5 BTC and return the 0.1 BTC. It will go to my wallet. Okay, 0.1 BTC. Right. All the information is available. Who sent you the amount? Okay. Right. Okay. This information will be stored in the blockchain. Still, the information is available. Who sent you the amount or who sent you the message? Okay, but that is not a decentralized system. That is actually centralized system. This is the major drawback. Okay, all that in the centralized system, all the transactions are not linked to each other. Okay, all the transactions are independently. Okay, if someone do some changes in any one transaction, so it will be very difficult to find out. Okay, but someone tell you, then someone change the database, then you will try to find out what happened in my database. Okay, but before this, it is very difficult. But in case of the blockchain, all the transactions will be saved in the block, and all the blocks are connected to each other cryptographically, as I explained in the previous slides. Okay, because for example, 504, the hash value of the 504 will be saved in the for example, 503 block, the hash value of the 503 will be stored in the 504. Okay, if you do the some changes at the 503, then it will flash one error that is something is wrong on the 503, and all the subsequent blocks will be invalid. Right. These are the few sites of the blockchain demo. You can do the practical. This is the comparison of the blockchain types. As I earlier in the beginning, the blockchain can be created in the 3 mode: public, private, and the consortium. Few people say consortium, federated, hybrid mode. The meaning is the same. Okay, public means permissionless, that is open to everyone can join, that is the permissionless. For example, Bitcoin is the best example, that is the public blockchain, right? Anyone can join, it is the permissionless. Private, permission, only you require, before joining the blockchain network, you require a permission. Okay, only authorized users are allowed, right? And the hybrid or consortium mode, permission is also permission. I mean, private means only single organization, that is the private. Okay, but more than one organizations are doing work jointly. For example, in the my slide, BMW and Ford created a consortium for vehicle identification. Okay, that is the consortium blockchain, more than one. Okay, that is not a private, that is a consortium blockchain. And the consensus algorithm, and the second property is the efficiency. The efficiency of the public blockchain is low because the users are very high. Users are very users are very high, users are large. Okay, and the private, in case of the private, the efficiency is very high because the users are very less. Okay, same in the consortium mode, the efficiency is high. And the next property is the read, open to public, anyone can read. But in case of the private, can be public or restricted. It depends on the authorization, right? They can be public or they can be private mode. Hybrid, it can be public or the restricted, same features. Immutability, tampering is not possible public because the users, as I explained, because blockchain technology works on the decentralized system. Okay, you cannot do the changes on the one one system. Okay, you suppose you want to change in the blockchain, you have to hack the more than 51%. Okay, for example, 100 system in one network, so you have to hack the 51 systems or 51 nodes. Okay, then private, possible to tampering high rather than to the public because the network of the private is very less, so that's why the chances is high in case of the private. Same in the consortium mode. Okay, right, examples of the permissionless public blockchain: Bitcoin, Ethereum, Bitcoin, Neo. These are the examples of the public blockchain. And the private में जैसे multi-chain आपका platform है, Hyperledger Fabric है, Hyperledger Sawtooth and Corda. Right. Public blockchain use cases, you can apply the public blockchain voting, which is the best example of the public blockchain, and the fundraising, right? And the private, you can apply supply chain, asset ownership, internal voting. and the hybrid banking and payments, research and post. Private and the consortium almost the same. It depends on if there is a one organization, that is a private. Okay, if more than one organization, that is the consortium. Yes. Bitcoin transaction approval time. Actually, Bitcoin network is the transaction approval time of the Bitcoin is the 10 minutes. Okay. Okay. Transactions per second up to 12. Level of the decentralization high because the users high. Okay. Types of blockchain is the public. Ethereum. It is good platform than the Bitcoin. Okay. The transaction approval time is 30, and the level of the decentralization high. Types of the blockchain public. Okay. This is another platform US. Transaction approval 5. Just I'm comparing of the platform. That's nothing else. Actually, Bitcoin is the first application of the blockchain, so that's why it consumes a lots of energy and the processing time is very slow. Okay. In case of the Ethereum, the processing time is very high. Right. US platform, the transaction approval time the 5 seconds and the transaction per second from 1,000 to millions. Million transaction can be generated. Level of the decentralization minimal. Types of the blockchain. That's why the level of the decentralization is minimal because the private network is always small. It is not big as public network. Okay, so that's why the level of the decentralization is minimal. Nero chain, it is the transaction approval time the 3 seconds. Okay, and transaction per second the few thousand transaction per second, and the level of the decentralization high, and the types of the public. Right? I mean to say latest platforms performance are very high rather than the beginning platforms. For example, Bitcoin is the first, and then came the Ethereum. Okay, rather than these two platforms. So okay, the latest platforms, the I mean processing time is very high. Okay. Yes. Gulfam sir, is over from my side. Please, any participant have any query, please ask me. House is open.
Dear participants, if anybody else want to ask any question or any query, then put up your question now. Dr. Khalil Ahmed is among us. Then proceed.
Sir, I have a question. Hello.
Yes, please.
Sir, what is the difference between the distributed and decentralized blockchain technology? Hello?
Yes, yes.
Am I audible, sir?
Decentralized and yeah. Are you asking the distributed computing or the decentralized?
Distributed and decentralized blockchain technology. Is there any difference, sir? I want to know.
I think there is no difference. I think it is a part of the DLT is a part of the distributed. So that's why they brought this technology in the blockchain.
Okay. Thank you. Thank you.
Any other participants? Adina? I think that there is no question from the participants. Now it's a time to wind up the second session. Thank you, sir. Thank you very much to spare some time with us and enlighten us for the knowledgeable talk. Inshallah, in future I will call you in the Baba Ghulam Shah Badshah University, Rajouri, Jammu and Kashmir, in the lap of the Pir Panjal mountain range of Himalaya. It is a very green and lush campus in the Pir Panjal range of mountain. Inshallah, in future, in the physical, while we organize any program in the physical mode, then I will invite definitely. Thank you, sir. Thank you again.
Thank you, Gulfam sir. Sure.
Dear participants, now within 5 or 10 minutes, we are going to start the session third, and our next resource person shortly join us. Wait for some time. Announcement, I have shared the attendance link in the chat box. Then respected participants can secure your attendance with the clicking on the link, and then it will be stored in our database. Thank you. Now our resource person, Dr. Faisal Anwar, is among us. I request to the Hanifa, please let us start the session.
Okay, sir. Good evening and a warm welcome to all of you. I'm honored to introduce our third speaker, Dr. Faisal Anwar. Dr. Faisal Anwar is working as an assistant professor in Department of Computer Science, AMU, Aligarh. He holds PhD in Information Security and Master degree in Computer Science from Jamia Millia Islamia, New Delhi. Joining AMU, he works as a software engineer in Computer Science Corporation, Noida. He has also worked with CSC UK as a software developer. His research area and special interests include cryptography, program, security testing, and machine learning. He has published several research papers in SCI, Scope, Index, Journal, and international national conferences. Dr. Faisal is also contributing as assistant coordinator of a NEP cell, AMU, and delivered several lectures in UGC organized workshops. With all respect and love, give a warm welcome to Dr. Faisal Anwar.
Thank you, ma'am. Am I audible to all of you? Can anyone confirm?
Yes, sir.
Okay, thank you. Thank you, the coordinator of this workshop, for giving me an opportunity to share my experience and knowledge on cryptography, especially on asymmetric key cryptography. You might have attended one of the lecture related to elliptic curve cryptography, which is also a asymmetric key cryptography. So I will discuss some other asymmetric key cryptography, and the very popular cryptography technique that is RSA. And RSA is one of the most popular asymmetric key cryptography. So the focus of my study will be related to RSA. And if time will permit, then I will discuss ECC as well, if time will permit. So we'll discuss the following contents: cryptography, symmetric key and asymmetric key encryption, trapdoor one-way function and their use in a symmetric key crypto system, RSA crypto system, and ECC, elliptic curve cryptography, if time will permit. So as we know, cryptography, actually we want to have some secure communication. Whether the data in transit or stored data, we want to secure our data. So for that purpose, we are having different type of cryptographic techniques. Similarly, if you want to ensure that the data that is coming to us is coming from authorized person, is coming from actually the one who wants to send those data, like, so that is called authentication, or you could say digital signature. You know, we want to verify one's identity, those who are sending certain information to us using the digital signature. It is very similar to the physical document, right? The document that we are receiving from our chairperson, dean, so they are having their own signature. In that way, we can confirm that this is the authentic document, right? The same concept is in digital world as well. If we are having digitally signed document, then we can say this is actually legal document, right? This is actually a document sent by the authorized user. So that is the concept of authentication. And for all these purposes, we are having cryptographic technique. And you know, cryptographic techniques are very popular in the sense the whole internet world, the whole computer system, these all are actually based on cryptographic techniques. If you will open any website, suppose you are opening a website of mu.ac.in, suppose, and in any university's website or any website, any commercial website or any e-commerce website, so there always you will see a log just beside the URL. You might have observed it. So that log actually says this that the whole transaction, the whole data that is going through this website is secure, right? So it is very important. If you are using any website, if that website is having open log, you should never use those websites, especially if you are having any account on those websites and you are providing credentials. So you should never use those websites. Can anyone confirm me if you have ever seen the log in any website? Yes, any one of you? So have you ever observed a log in your website, in any website, and you try to observe and to try to find out why there is a log and what is the purpose of that log? Yes, any one of you? I want to have this session very interactive, so it should be a two-way session instead of one-way communication. Yes, any one of you? Let me show you if I can. I'm just sharing a website here, and I will try to show you how actually how you can observe any website cryptographic algorithm or their related keys. Let me show you a website here. So just a minute. I'm just using mu.ac.in. Is this website visible to all of you? Yes, can anyone confirm me? This website is visible to you? Yes, any one of you?
Yes, sir, it's visible.
Yes, yes. So in that website, you can see here there is a log, right? So why there is a log? The question is why there is a having log. And you know the similar cases with your WhatsApp application. When you send WhatsApp claim that the message that is being sent to the different parties, suppose you are sending a message to X, any user X. So this message is end-to-end encrypted. It means this message can only be viewed or read by the user for which you are sending those message. If any attacker or any unwanted person, if they want to read those messages, they would not be able to do so because those messages are in encrypted form. So you can observe, just open your WhatsApp and try to open personal contacts of any friend, and there you can see a code. I think 26 digit of code. So that code would be similar with when you will observe. Suppose I'm trying to send a message to X. So just go to your X contact in WhatsApp. You will see a set of digits, and that digit would be similar in an X contact of me, X WhatsApp contact of me. If you will ask their mobile number, suppose X mobile number, and just go through the WhatsApp contact list and try to go to my contact, then you will observe the similar pattern, similar digit, exact digit actually. So it means your contact, your message which you are trying to send between X WhatsApp through Y WhatsApp, this message is in encrypted form. So that is the purpose of end-to-end encryption. And it is very important. If it is not end-to-end encryption, it means anyone can read these information, any attacker. Even WhatsApp claim that WhatsApp is not aware of whatever the data that you are sending. So even they are not able to read your data because it is end-to-end encrypted using certain algorithm. You might have gone through elliptical cryptography. So WhatsApp use elliptical cryptography for encrypting their messages. No, like in this case, you have there is a lock in this URL. So what does it mean? It means all the transactions are encrypted. Actually, how it works? This is a client-server architecture. Website works in the format of client-server architecture. So if I am typing amy.ac.in, it means a request has been generated, and that request will be sent to first DNS, domain name server. Domain name server will provide IP address, right? And that IP address will be sent in individual packets. And in that individual packets, this individual packet will be in encrypted form. Then the message will be that then this request will be sent to the web server. Like suppose you are typing amy.ac.in from your machine. So the request will be sent to our server. It is there at our location. So that request will be in encrypted form. And our web server will decrypt that message and will get the actual information. Suppose you are requesting Department of Computer Science page, right? So our web server, MU's web server will decrypt that information, and then it will send the data in the form of response, and that response would also be in encrypted form. That will be decrypted here at our client side. Okay. So it is very important to have this type of encryption technique. Like in this case, I'm typing login here. So if I am providing employee ID and credentials, so all data would be in in encrypted form. When I was doing PhD, at that it's a long back. So I visited one organization, and in that organization they were using their mail server, their local mail server, and that was not Gmail server. They are having their own mail server. So I installed a tool that is called Wireshark. So Wireshark is a very specialized tool, and if you will install Wireshark in any machine, run it, so you would be able to assess the traffic, the packet that is going from one machine to another machine, and you would be able to read the data. But since nowadays we are following encrypted data, so if anyone would be able to read the data using Wireshark tool, so those data would be in encrypted form. But the organization that I visited long back, it's I think 15 years back. So they were using a local mail server, and that local mail server was not having a lock. It means they are using the protocol that is HTTP, plain HTTP protocol. So what happened when I installed Wireshark tool? So one of my professor was there. So I gave them, said it is your password, and so he was very much surprised how you get this information. So I told them that, sir, because the local mail server is not in encrypted form. So it is very important to have log in each and every website. If a website is not using proper encryption mechanism, so for that purpose this log will be open. Like in this case, so let me show you which algorithm our web server is using. So you will go to that log, and there it is, connection is secure. Just click it and you will get the certificate is valid. So just press it and you will see several information here. So just go to in detail. So Global Sign is actually the company that has issued the certificate. It means they have given a certificate for 1 year. Yearly we need to renew it. So it is valid, I think, till September. It is written here. Expire on Monday, October 16. October 16. So after that we need to renew it. So here you can find which algorithm is being used for encryption, and since if asymmetric key is being used, then what is the key, public key? So you can see here. Let me show you the algorithm. Like if you would press, you will see RSA encryption. It means this website, our web server is using RSA algorithm to encrypt and decrypt the data. And there you will see the key, public key of AMU web server. You can see here. So it's a 2048 bits key. It's a very long key. And then if you know the public key encryption system, so each party used to maintain two different keys, public key and private key, right? So that is the purpose of public key. Public key is used to encrypt the data, and it depends, using public key you can also encrypt the data, and private key can also be used to encrypt the data, but the purpose would be different. If you are using confidentiality, if your if you want to encrypt your data, if you want to encrypt the data to be stored in cloud or somewhere else. So for the encryption purpose, you will use the public key of the receiver, right? And if your intention is to have signature verification or digital signature creation, so in that case you will use your own private key to encrypt the data. So that is the intention is different. So one is confidentiality, another is one is authentication. So that's why it is very important to each and every website should have a proper log and you know, they should properly purchase a certificate, and yearly they need to renew it. So that is the purpose of certificate in this case. Like certificate, we are viewing the certificate of emu.ac.in, right? So there are some other information as well that you can explore here, and like SHA-256 is used for message authentication and integrity. So there are different purposes of algorithm that is being used. Now let me come to the PPT. Is it clear to you what is the purpose of certificate and what is the purpose of lock here? Yes, any one of you? Is it clear to you, to all of you? Yes, any one of you? Is there any question related to this particular concept? Actually, what I'm trying to show you, this is something that we used to observe daily, right? But we have not paid attention anywhere. But it is very common. It is very common to have this type of information, right? Now, let me share the original PPT that I was discussing. Yes. So now come to cryptography. So area we study related to converting plain text into ciphertext. So the main task is to convert plain text into ciphertext. That is an encryption process, and decryption process, the process of converting plain text into ciphertext is called encryption, and decryption is the process of converting ciphertext into plain text, that is called decryption. Then what is cipher? Cipher is actually an algorithm used to encrypt and decrypt text, like RSA is a cipher, and then ECC, Diffie-Hellman, and then El-Gamal. So there are different algorithms. Key, the set of parameters that guide a cipher, it is very important to have a proper key. In general, what happens, algorithms are known to each and every party. Whatever algorithm you are using, RSA is known to each and every party, ECC, how it works, how ECC works, how Diffie-Hellman works. So everyone knows. The main thing that are not known by the attacker, by the by the user, different users, this is key. And in that secret key, actually, public key is known to each and every party. So this is the main important building block of whole cryptographic system, because algorithm is known to each and every party. So the target is to make a stronger key, so that no one can deduce your key, no one can guess the data. So that is the purpose. Cryptanalysis, there is one more concept that is called cryptanalysis, the process of decrypting a message without knowing the cipher or the key used to decrypt it. It means what actually attacker used to do. They want to get the data based on the ciphertext, based on the since they are not having key, right? So they will try to fetch the data using the existing ciphertext. So they used to have different type of technique, like brute force technique. They will explore brute force technique to get the data. So that is the task of cryptanalysis. Let me give me just a minute. Someone is waiting. So that is a cryptanalysis. Then how asymmetric key algorithm works. So like in this case, you can observe this figure. There is two parties. There are two parties actually, Bob and Alice. Bob wants to send certain data to Alice. And Bob would have public key of each and every party. Bob's public key ring, it means Bob would have public key of Joy, Mike, Alice, Ted. So public key is known to each and every party. Like I have tried to show you the public key of amu.ac.in, our own web server. So public key is known to each and every party. So using the public key, Bob would encrypt a plain text input. Input could be in the form of file. It could be in the form of your voice message. It could be in the form of image. So anything can be in the form of anything can be as an input. And so that input would be encrypted using the public key of Alice. If Bob wants to send a message to Alice, so Bob would use public key of Alice to encrypt the data. Now, when this data would come to Alice, so Alice would use their own private key to decrypt the message, to decrypt the file or image or anything. So it could be any multimedia, right? So these public and private key are related to each other. But public key and private keys are created on the basis of trapdoor one-way function. That will later on we'll discuss what is trapdoor one-way function. It means although they are related, but no one can find out the other key if they get anyhow if they get one key, right? If someone gets the public key, they cannot deduce the private key. So that is the whole I will say the main foundation of any asymmetric key algorithm, that is trapdoor one-way function. It means if you are not giving a certain information, that is trapdoor, then no one can deduce the data. That later on we'll discuss certain functionality of trapdoor different type of functions of trapdoor one-way function. So asymmetric key encryption schemes use two separate keys, one private and one public, that we know. Public key known by anybody and can be used to encrypt message and verify signatures. And then one thing is important. So public key can be used to encrypt the message as well as verify signature. What does it mean? Verify signatures. It means, as I told you, if Bob wants to send message to Alice, so what he will do? He will use Alice public key to encrypt the message, right? And then the message will be transferred to the Alice. But if Alice want to, verify the authentication of Bob, so what? For that purpose, Bob would encrypt the whole message using his own private key, and that would be collab with the encrypted message. So this encrypted message would be something. This is the encrypted message, the original plain text message, and there would be a digital signature in the form of. So what a digital signature is? It is actually the message encrypted with the private key of Bob. When it will be received by the Alice, so Alice will do first. It will decrypt the message using the Bob's public key. So if they would be able, if Alice would be able to decrypt the message, it means the message is actually coming from Bob's side. Then Alice would decrypt the message using his own private key to get the actual plain text, So that is the purpose of verify signature. So a related private key known only to the receipt used to decrypt messages and sign creation. Signature to create the signature, like in this case we have seen. And Alice will verify that signature. So examples are RSA, ECC, Diffie-Hellman, and El Gamal, and several more. So there are different asymmetric key algorithms. So can be applied into 3 categories: data confidentiality, data authentication that we have seen, like digital signature, and key exchange as well. It is very important, you know, key exchange is one of the main catalyst. Because of that, asymmetric key came into market, came into, you know, exist. Before asymmetric key algorithm, people were using symmetric key technique. But the main challenge with the symmetric key algorithm was how to share the key. So one possible way was to have a high level meeting, high level delegation, you know, and then on the basis of that, you know, in that high level meeting, they will share the key. Okay, later on they will, you know, communicate using this key. But as far as digital era is concerned, this is not, you know, a very valid option. So for that purpose, asymmetric key algorithm was proposed, and Diffie-Hellman was the, you know, pioneer in that key exchange. They have developed a Diffie-Hellman algorithm that is the one of the most, I would say, one of the main breakthrough in asymmetric key cryptographic techniques. They have proposed a very innovative idea through which, you know, users can communicate secret key or private key without physically sharing the data, right? So that's why the main intention was to have key exchange. So their task was not to encrypt or decrypt the data. Their task was to have a session key or secret key that would be useful for a particular session. Like you go to, you know, Flipkart or Amazon. So once you log in, a session is created at backend, right? And in that session, a unique key is generated. So all the communication would be performed using that unique key. And that is the very you know, innovative idea, because no other participant, no other user or any attacker can interfere with your session, because each and every session would have a different unique key, and that would be very tough to decrypt. So all the transaction would be on the basis of that unique key. So if attacker wants to hijack your you know, session, so they should be able to, you know, get the key. If they are not having key, session key, one-time session key, so they cannot you know, hijack your session. So in that context, Diffie-Hellman was the very first who introduced key exchange mechanism. Otherwise, RSA and elliptic curve, they can be used. These algorithms can be used for encryption, decryption, digital signature, key exchange. So RSA. So first Diffie-Hellman was proposed, then RSA, and then finally elliptic curve was proposed. As I told you, whole asymmetric key requirements are based on trapdoor one-way function. So what is trapdoor one-way function? Suppose you are having you know, a function for which you can you can compute something, right? Suppose there is a function that is called Euler-Phi function that is used to find all the relative prime numbers less than n. Relative prime numbers less than n. So if n is n1 into n2, and where n1 and n2 are very large prime numbers, that is the basis of RSA. n1 and n2 are very large prime numbers. And so if you need to find out the phi n, it means Euler-Phi function. So it can directly be find out n1 minus 1 and into n2 minus 1, right? So you can calculate phi n, but if you are having n, So you cannot find phi n. So that is the one-way function. It means if you are having n, then you can find phi n. But if you are having phi n, so I mean using other side, it is not possible. Let me show you one scenario. Like you are suppose someone is very keen to play billiards, and he is using billiards to suppose in an empty room. He or she is alone, and using his stick or her stick, he or she is trying to hit the ball. So according to certain rule, he set a rule, right? Using my stick, I will first hit in this direction. If I will hit that ball in this direction, so probably the ball would touch the boundaries of that board, and at last it would rest at some point. Right. So he has established certain angle or certain direction through which to hit that. Suppose he has or she has hit that ball. Now the ball, after touching the different boundaries, now it is at rest. Now suppose some other person came into that room and he has saw that ball at that position. So he or she, the person that is coming from outside, cannot deduce that from which direction that ball has been hit because of that position. So that is not possible. So that is actually one-way function. It means you can do something, but undo is very tough. Undo is NP hard type of problem. So that is called one-way function. So that is the task. It means in RSA algorithm there are different type of functions that different type of one-way and trapdoor one-way function. So this is one-way function. Trapdoor is something more specialized one-way function in which there is a trick. If that trick is known, then we can deduce that function. Like in RSA algorithm, we used to have this type of 1 mod phi n, this type of function. So, and D is calculated like E inverse mod phi n. So if you know E and phi n, then you can calculate D, right? If you know E and phi n, then you can calculate like in this case. So it is possible. And similarly, you can calculate, if you know D, then you can calculate E, like in this case, E is equal to D inverse mod phi n. It is also possible. But if phi n is not known and E is known, but phi n is not known, then D cannot be calculated. So that is trapdoor one-way function. And the whole RSA is based on this type of function, trapdoor one-way function, because this is the public key, or anything you can consider private key as well. So this is, suppose this is public key and this is the private key. So in this way, actually they used to generate public key and private key. So a practical asymmetric key scheme depends on a suitable trapdoor one-way function, like ECC as well. ECC is also based on discrete logarithmic problem. So that is again a one-way function. So RSA scheme, the most common asymmetric public key algorithm is the RSA crypto system, named for its inventor Rivest, Shamir, and Adelman. Later on they got Turing Award as well because of their cryptographic techniques. So Turing Award, it is supposed to be a Nobel Prize in computer science. So it's a very high level of prize, that is Turing Award. So they got this prize because of their inventions in cryptographic techniques. Now, how actually RSA works? So to encrypt a message M, So each and every sender would have, suppose A and B. So each sender would have public key and private key, EAN and DAN. So this is the public key and this one is the private key of A. Similarly, there would be a public key and private key of B as well. So this is the public key and private key of A and B. To encrypt the message, so suppose A wants to send message to B. So what A will do? A will use B's public key to encrypt the message. So here A will actually encrypt message using the public key of B, using in this fashion. C is equal to MEB mod N, where is N is actually based on certain N1 cross N2, where N1 and N2 are very large prime numbers. Okay. So in this way, they actually calculate the ciphertext. So no one can be if B wants to decrypt that message. So what we will do, we will get the plain text using this function C D B N, right? So we will use their private key to decrypt the message. So in this way, they will get the message. So that is the whole mathematical component behind RSA, right? So this is the way of encryption and decryption, how encryption and decryption will be performed in RSA algorithm. So before encryption and decryption, each and every party first agree on certain global parameters, certain common parameters. Suppose you have design your own website, and you want to be your website to be secure. So in that case, what you will do, you will consult different companies like Global Sign that our AMU has taken the certificate. So you contacted the Global Sign, and what they will do, they will first set up your public key and private key. And how they will set up their public key and private key, so that we will discuss in this slide. So first they will ask to select two very large prime numbers, and you can say very large, it means very large bits, 2048 bits number. So it's a very huge number. If you will take 10 bits number, so the maximum number could be 10 to the power 10 and minus 1. So this is the maximum number that you can store in 10 bits, right? And what is this number? 2010 is actually 1024. 1024 minus 1. This is 1023. This is the number that you can store if you are having 10 bits. And imagine if you are having 2048 bits. So how much huge number it is? 2048 minus 1. It's a very huge number, right? Because 2 to the power 10 is only 1023. So you can consider 2048 minus 1. So first you need to select two prime numbers, P and Q, and the very large prime numbers. And then N will be calculated in this way. N is equal to P into Q, like in this case. Now, Euler phi function, Euler totient function actually. So that will be calculated using this manner, P minus 1 into Q minus 1. It means phi N is actually all the relative prime numbers less than N. Relative prime number, it means suppose you are having 10. So relative prime numbers are 3, and then 5, 6, 7, then 9, right? So these numbers are whose GCD are actually greatest common divisor is 1. GCD of all these numbers 1, 3, 7, 9 with 10 is you will find GCD is 1, greatest common divisor. So that is the purpose. So in this way, you will get all those numbers. So it will give you count of that numbers. Like in this case, the count is 4, right? Count is 4. So 5n would return 4 in that case. But for very large number, 5n would be very large, right? So after that, the next process is, this is the very first task. Then second is this one. Third is, they will ask you to select a number less than 5n. Randomly select a number less than 5n. Suppose 5n is 7. 5n is 7. So they will ask to select a number less than 5n. Suppose you have selected 2. Such that the GCD of that selected number and 5n should be 1. It means these two, the number that you have selected should be relative prime with 5n. And the purpose of finding that number is actually because if you two numbers are relative prime, it means you can find the inverse of that number. Otherwise, inverse is, in some cases, inverse would not be possible. So you have, suppose you have taken that number E, then you need to solve this equation that I discussed in previous slide. So you have already selected E, right? E is known. Then D will be calculated. How D will be calculated? So D is equal to E inverse mod phi n. In this way, it would be calculated. Finally, you have calculated E as well as D. So you will publish your public key E with N, and you will keep with you the private number, that is D with N. So that is the whole key setup, key generation technique. How RSA actually, I tried to show you an example here. Suppose you are sending how are you. So equivalent integer number would be fetched of H, O, W, and A, R, U. The equivalent integer number, suppose you are having A to Z alphabets. So A will be assigned 0, and then B will be 1, and so on. Z will be 25. So equivalent integers. Similarly, if there are some other special characters, so accordingly you will assign certain integer numbers. So each has been given certain numbers, like in this case. Now, the very first process will be, like in this case, to generate E and D. So you have, suppose you have selected a prime number P as 73, Q as 151. Then you get the number E. E is equal to 1. E is equal to 1. How you have selected? E should be a random number less than 5n, right? Less than 5n. And on the basis of E, you calculated D. Like in this case, D is actually E inverse mod 5n. Then you have calculated D, and then finally you get the number E and N, right? So this one is private key, and this one is the public key. Now using the public key, now you will encrypt the message, like in this case. So individually there are several, you actually club two different characters, right? So by clubbing two different characters, you try to encrypt the message. So at a time, two characters would be clubbed, and accordingly they would be encrypted. And why we are clubbing two different characters? Because my number is modulus is 5-digit number. So I want to restrict my message to be less than modulus n. If my message is greater than modulus n, then I will break the message into different blocks that should be less than n, modulus n. So now individually I will encrypt this message again using the technique M D mod phi n. So this is the way. Then it will be transmitted, and finally at the receiver end they will decrypt the message. So this is the way of encryption and decryption. As far as implementation of RSA is using Python, we'll use generate key pair, encrypt. So first we'll generate the key pair, then encrypt and decrypt, and then multiplicative inverse. So these different functions we'll be using. So very soon I will come to the core Python code of RSA. If you would categorize the different works of RSA, so huge number of papers you will find as far as RSA is concerned. So in 2 years back, we had published an ACI paper in survey of RSA, and we found there are different areas in which RSA is being used, like hybrid, cloud, multi-keys generation, digital signature, batch, image classification, k-nearest program, wireless network. So there are different number of areas where RSA works have been observed. There are several variants of RSA as well, like XRSA. This method was proposed by me, and then there are some more works in this direction. So this is RSA, XRSA comparison. If you are interested in writing a paper in, suppose, in any cryptographic algorithm, so you need to compare the encryption time, how much encryption time your algorithm is taking. Similarly, you need to find out the encryption key generation time and decryption time as well. So first you need to find out the time of key generation. Then you need to find out the time for encryption as well as for decryption. So this is the, in this way, you will compare with the existing methods. Similarly, there is one more parameter through which you can compare, that is called avalanche effect. So avalanche effect is actually, it says if you are changing at in one bit of your message, then almost 40 to more than 40% of bits of ciphertext should be changed, right? Suppose you have generated a ciphertext on the basis of plain text, and and suppose you are using an algorithm, cryptographic algorithm, say, let's say X, and if you want to check that your method is effective or not, like X method is effective or not, so one parameter to check the effectiveness of X is you will try to change one bit of plain text, and you will observe how much bits of ciphertext has been changed. If the change is greater than 40% or 45%, so it means your method would be acceptable. So that is called avalanche effect. So this is one more parameter to check. Then similarly, if you are developing your own new method, then you will use brute force technique as well. So brute force through which, exploring each and every option for getting the keys or message. So this is the, as far as theoretical concept is concerned, RSA. So I discussed all the theoretical concept related to RSA, and then now I will discuss its implementation. I hope I am time. Okay. So as far as implementation is concerned, so implementation has been divided into 4 different, sub-modules. So first we'll use generate key pair. Generate key pair, it means we are interested in generating E, N, and T, N. Right? This is the public key and this is the private key. So in this very first module, we'll generate public key and private key. Then encrypt, it means using the public key of other party to whom you are actually interested in sending a message. So you will use public key of that party and then the actual message. So this is the second task. Then third task would be decrypting. Decrypt. What you will decrypt? You will decrypt the encrypted message performed in step 2 using the private key of the other party, right? So in this way you will decrypt the message. I mean, if I need to decrypt the message, so I will use my own private key, right? And then multiplicative inverse, it means suppose multiplicative inverse, if you are having EAD is equal to 1 mod phi n, and you need to find out E, suppose D. So E inverse mod phi n. So how we will calculate the inverse, multiplicative inverse? So this E inverse will be calculated using this function that is called multiplicative inverse, right? So it would accept E and phi n, this one phi n. So it will accept these two parameters and it will generate T actually. So is it clear to you till now? Yes, any one of you? Or you may be exhausted, by attending all the lectures. Okay, let me show you the code of that RSA algorithm. I'm just sharing one more window. Let me share the window now. There it is. Yes. Is it visible to you? The code is visible to you? Yes, anyone can tell me?
Yes, sir, code is visible.
Okay, thank you.
Source code is
how? Yes, thank you so much. How we will start? Your Python code would start from here from main, right? So we are taking input as a two prime numbers. First, I told you, first we need to find out two prime numbers. I have used, in this program, user is actually entering prime numbers. But in real scenario, two random prime numbers are actually generated. For generating prime numbers, random prime numbers, we are having different type of algorithms. Like one of the very popular algorithm that is called Miller-Rabin primality test. So using Miller-Rabin primality test, we can generate a unique prime number, right? So in that case, we need not to enter the prime number, because if suppose you are using 1024 bits number. So how can I remember this big prime number, right? I can remember till suppose 153 is a prime number, 250, suppose 253 is a prime number, but I cannot count huge prime numbers. I cannot remember, right? So for that purpose, we can have Miller-Rabin primality test through which we can get the prime numbers. So this is the very first task. You need to get the prime numbers, two prime numbers. And then on the basis of these two prime numbers, I will generate key pair, public key and private key. That I told you, that is the very first task is to generate the public key and private key. So I will call this function generate key pair. So this is the function. It's a very, very simple function. If P and Q are, it's P and Q are not prime, then it will raise an error. That because the whole RSA algorithm works on two random prime numbers. So that is the very first step. It's actually prerequisite that P and Q should be prime number. If both are equal, then again it will generate a message or error that P and Q should not be equal. Then it will calculate n is equal to P into Q. So this is the number n. N will always be public, would be known to each and every party. I told you this is the global parameter n. Then on the basis of n, we will calculate phi n, Euler-Tauschant value. And this is actually P minus 1 and Q minus 1. And this phi is not known to any party, right? Because phi if you are having very large prime numbers, let's say 2048 bits, and you have calculated n, so you cannot guess phi n. It's a NP-hard problem, right? Now, if suppose you have already calculated phi, then we will calculate we'll take a random number, that is E, which is less than phi n, and such a way its GCD of with phi should be 1. Like in this case, I have selected a random number, and then I have taken GCD of E with phi, right? Why I'm taking GCD? GCD, it means greatest common divisor. So I am calculating GCD because the GCD of these two numbers should be 1. 1, it means these two numbers are relative prime. Okay. So if the two numbers are relative prime, then and that case only inverse would be calculated. Inverse can be calculated, right? So the task of this line of code is to generate E, suitable E, in such a way that E and GCD of E and phi n should be 1. Then after that, D will be calculated using multiplicative inverse function. So the task of this function is to generate multiplicative inverse of E that I told you in last slide, right? So it will be called and D will be calculated. So in this way, I will return E comma n. This is the public key, E comma n. And the next one is D comma n. This is the private key. So private key of one party, right? So this public key and private key is actually related to single party. Okay. If some other party want to be the part of this secure transmission, then they will again they will create their own public key and private key using RS algorithm, right? If they are using RS algorithm. So that is the very first task, to generate public key and private key. Then after that, so this at that point of time, we are having public key and private key, right? Now I have calculated, time as well, so that I can get to know how much time is being taken to generate public key and private key. So that is the task here. So I have calculated total key generation time, and I have published here total key generation time, right? So this is the task of key setup process. Then encryption process, it will be started. So I will, I will ask to input certain message, so that I will decrypt I will encrypt that message. So I have asked user, I requested user to enter certain message that will be encrypted actually. Then again, I have taken time so that I can get to know how much time has been taken in encryption, right? After that, this is the main function that will be called for encrypting the message, and it will observe public key and message. Public key is public key of जिसको हम भेजना चाहते हैं, the party to which I am interested to send the message. So public key of that party, and then message is actually the message that you want to send, send in encrypted form. Again, this function will be called encrypt, and the task is of this encrypt is first what I am doing. I am suppose someone has entered ALIG, right? So I have calculated a sky value of A, a sky value of L, a sky value of I, a sky value of J, like in this case, a sky value of I, and then ALIG. And then I calculated M to the power D, that is the a key of public key of one of the party, right? Public key E, and then N. N, it means this is a special function power. So what actually the third parameter will perform? It is N is for modulus N. So I want to have the function C is equal to M to the power E mod N. So for that purpose, I am using N. So it will generate the ciphertext, and then I am returning the ciphertext. So this is the task of encrypting the message. And then again, for decrypting the message, the same process will be performed, but with certain different keys, right? So decrypt, what decrypt will do? So this is the function. So it will decrypt the actual encrypted message with the private key of one of the party. Suppose I am receiving this message. So what I will do, I will use my own private key to decrypt the message. So in this way, decrypt the function would work. This is the decrypt, very, very small function for character in ciphertext. So no individual character will be used, and their power, what is performing here. I'm taking character. It means the cipher character. Suppose somehow Alig is replaced with A, B, C, D. Suppose. So I'm taking A. I'm using C to the power D mod n, right? So here key would be private key, and then n is modulus. So in this way, they will generate the plain text, and it will be returned here in this case. And yes, so it would be written here decrypted message, and decrypted message, this message and the plain text message should be equal, right? So that is the way. Let me run this one. I'm just executing this one, and suppose I have entered Aligarh, right? Oh, sorry. I need to first enter prime number. Let me enter a prime number.
Enter prime number, yeah. We need to enter prime number.
Yes, sorry. So
yes.
23 and then suppose 43, two prime numbers, right? And then n has been generated. N is actually p into q. Then Euler-Tauschent function value, that is p minus 1 into q minus 1, that is 924. And this is the public key and private key. So A is the public key and private key. So our message would be so key setup has been performed. So this is the way of setting the keys, right? Now I'm entering the actual message. So this message, I got the ciphertext in the form of integers. So this is the integer form of A, and then LIG. So this is the this one is the somehow we use the function like m to the power e mod n, like so. In this way, I have calculated the encrypted message, and then that will be decrypted using the private key that we have already generated, right? So private key is 999, and this is the n. So in this way, it has been decrypted. So this is the way we can code RSA. I have used plain Python to implement the RSA. There is one more specialized package of Python that is called SageMath. So you can use SageMath as well. In that package, you will find several inbuilt functions, right? Like inverse, you will get the function, because for multiplicative inverse, I need to write this set of lines. But for in SageMath, you will get a function for that inverse and several more. So this is all about asymmetric key algorithm and its implementation. And I stop here. And if you have any question and something that you want to discuss, now the session is open for any question answer. Yes, any one of you.
Can I ask one question?
Yes, sure, sir.
Yes, sir. Sir, P and Q is both are selected by user.
Yes,
N is calculated, phi n is calculated, and E is also selected by the user. So is there any formula to calculate private key D?
Private key. So actually private key has been calculated on the basis of E into D is equal to 1 mod phi n, right? So in this way, actually, suppose you have selected E as a random number, right? And that should be less than phi n. And in such a way, GCD of E phi n should be 1.
1.
Right? So
Yes,
you
sir.
have selected a random number E, right? And on the basis of E, you have calculated E into D is equal to 1 mod phi n. So this D you have calculated using E inverse mod phi n. So I've written a function for multiplicative inverse. So
Yes, yes.
multiplicative inverse can be calculated using extended Euclidean algorithm. Right? If you have heard about Euclidean algorithm and
Which
extended
algorithm?
Euclidean algorithm.
Which algorithm?
Extended Euclidean algorithm.
Okay. Yes, I heard about this algorithm.
So this inverse can be calculated using, so the code that I have shown you in multiplicative inverse, so I have used extended Euclidean algorithm, right? And for calculating GCD, greatest common divisor, Euclidean algorithm can be used.
Okay, sir. Thank you very much.
Apart from prime numbers, you told me about, I have selected prime numbers. So in very, beginning of our essay method, I already told you that if for this lecture, I have selected 2 prime numbers, especially I have designed my program. Otherwise, in real scenario, you actually select 2 very large random prime numbers, right? And that prime numbers can be selected using the Miller-Rabin primality testing algorithm. So that algorithm can be used to create 2 very large prime numbers, let's say 2048 bits. So we have implemented in our paper, then that paper
Yes,
we
sir.
had submitted. Yes, any one of you, if you have any more question.
Sir, one more question. Is
Yes, yes.
RSA vulnerable to any kind of cryptographic attack?
No, it's not actually, for that purpose, if quantum system would be implemented, so obviously all algorithm would be obsolete, right? But as of now, I assume it is my own statistics, 50 to 60% whole network, whether it is web-based application, whether it is a network communication across different domain, RSA algorithm is being used. And yes, if you are having a very huge machine and you have set up that type of machine, so it might be possible for some cases that it can be break. But as of now, there is no such data that RSA has been generalized. You cannot generalize that actually data. There are certain instances, but that cannot be generalized.
Okay, sir. So thank you very much.
Thank you so much, sir. Yes, any one of you, any more question? Yes, Gulfam sir, I think it's
The
over from my side.
participants, if anybody want to ask any question now, Dr. Faisal Anwar is among us. Please ask. He will define your query. Please. I think that there is no question from the audience and participants. Now it's a time to wind up the session. I request to the Hanifa is available among us.
Yes, sir.
Please.
And thank you, sir. And thank you to our last speaker of this session, Dr. Faisal Anwar, sir. Thank you once again, Faisal Anwar, sir. We appreciate your time and dedication to share our knowledge with us. Now it's time for end this session. The new session start will tomorrow at 11 a.m.
शुक्रिया डॉक्टर साहब, बहुत बहुत शुक्रिया सर, आपने हमारे साथ में हैं.
Thank you.
Inshallah, while we organize any workshop or FDP in the physical mode, then we shall invite you in the Baba Ghulam Sabad University campus. Really, it is a very green and lush campus in the Pir Panjal mountain range of Himalaya, and very interesting sceneries you can look over here. Thank you, sir. Thank you again.
Thank you so much. Thank you. Now I am exiting from this session, right?
Okay,
thank you so much.